Technologia VR, a więc rzeczywistości wirtualnej, jest narzędziem przyszłości edukacyjnej z powodzeniem wykorzystywanym już od dłuższego czasu w programach szkoleniowych spółki JSW Szkolenie i Górnictwo. Tamtejszy system VR jest tak skonfigurowany, iż może być rozbudowany o nowe komponenty edukacyjne. Najnowszym są fantomy, które współpracują z technologią VR, otwierając zupełnie nowe możliwości szkoleń z zakresu pierwszej pomocy przedmedycznej, a więc wiedzy i umiejętności, które mogą zdecydować o ludzkim życiu i zdrowiu.
Wykorzystywanie technik stricte praktycznych do nauki tak ważnej dziedziny, jaką jest niesienie pierwszej pomocy, pomocy przedmedycznej w zakładzie pracy, tutaj w tym przypadku jakim jest kopalnia oczywiście, jest bardzo ważne. Wiedza teoretyczna, znajomości podstawy zachowania się w pierwszym etapie jest bardzo ważne, ale praktykę, ćwiczenie tego właśnie z wykorzystaniem aplikacji VR, z wykorzystaniem fantomów, prawidłowe uciski, prawidłowe sprawdzanie oddechu. Jest to najważniejszy element i stąd właśnie pomysł w Spółce Szkolenie i Górnictwo, aby rozpocząć szkolenia wśród kadr, którzy mają świadczyć tą pierwszą pomoc przedmedyczną, tak zwani sanitariusze, aby ich poziom wiedzy właśnie z zakresu praktyki, bo teorię mają, jak najbardziej właśnie z nich wykrzesać i sprawić, aby gdy dojdzie do niesienia pomocy, ona była jak najbardziej skuteczna.
Fantomy z aplikacjami VR pozwalają na indywidualny tryb szkolenia praktycznego, które jest dostosowane do umiejętności i predyspozycji każdego kursanta. Wirtualny instruktor precyzyjnie kontroluje czynności ratownicze podejmowane przez uczestnika szkolenia. Aplikacja jest tak zaprojektowana, aby podpowiadać kursantowi właściwy sposób postępowania z korekcją błędów do momentu prawidłowego wykonania czynności ratowniczej.
Na tyle będą wypracowane powtórzenia, aby nabrać tego prawidłowego zachowania. Także wykorzystanie właśnie aplikacji w tym zakresie, stricte udzielania pierwszej pomocy jest najlepszą teraz formą szkolenia moim zdaniem.
Fantomy z aplikacją VR służą nie tylko do praktycznej nauki resuscytacji krążeniowo-oddechowej, czyli sztucznego oddychania i masażu serca, ale także prawidłowego korzystania z defibrylatorów.
Jak go prawidłowo elektrody rozmieścić, jakie po kolei czynności wykonać, aby jeżeli będzie konieczność użyć tego defibrylatora.
Zalety wirtualnego systemu nauki pierwszej pomocy doceniają także kursanci.
Właśnie jestem po skończonym szkoleniu VR. Jestem zaskoczony możliwościami tego projektu. Aplikacja daje mnóstwo możliwości rozwoju umiejętności praktycznych.
Spółka JSW Szkolenie i Górnictwo już teraz zaprasza wszystkich zainteresowanych zdobyciem wiedzy i umiejętności z zakresu pierwszej pomocy na bezpłatne zajęcia, które w ramach Dni Otwartych zaplanowano na czerwiec tego roku.
This is the 18th edition of the International Fair of Mining, combining 350 exhibitors from 12 countries, 26,000 square meters of space.
Please join us on the stage.
Zero, 152.
Województwo śląskie oferuje wiele rozwiązań dla biznesu. Natomiast Międzynarodowe Targi Katowice 2021 to wyjątkowe wydarzenie. Dlaczego warto się tu spotkać?
19. edycja Międzynarodowych Targów Górnictwa, Przemysłu Energetycznego i Hutniczego Katowice 2021 już przed nami. To jedno z największych wydarzeń w Europie i trzecie na świecie. Spotkamy się już między 7 a 10 września 2021 w Polsce, w Katowicach, w Międzynarodowym Centrum Kongresowym oraz na placu przed Spotkiem.
Nadchodząca edycja targów Katowice 2021 została wzbogacona o Międzynarodowe Targi Energetyczne B2 Energy Poland.
Jako organizatorzy przygotowaliśmy dla Państwa ponad 60 000 metrów kwadratowych powierzchni targowej.
Katowice jako serce województwa śląskiego to miasto otwarte na biznes i przyjazne inwestorom. Znajdujące się w nim Międzynarodowe Centrum Kongresowe to wyjątkowy obiekt, który został wyróżniony jako jeden z najlepszych kompleksów do organizacji konferencji, kongresów oraz targów w Polsce.
Oprócz naszych targów, Międzynarodowe Centrum Kongresowe gości również 5. Polski Kongres Górniczy, Europejski Kongres Gospodarczy i wiele innych.
Dla przemysłu istotna jest branża energetyczna i elektryczna, która podczas targów B2 Energy Poland Katowice 2021 ma doskonałą przestrzeń do prezentowania innowacyjnych urządzeń i technologii. Targi o charakterze międzynarodowym to świetna okazja do podjęcia współpracy z międzynarodowymi koncernami energetycznymi i odbiorcami końcowymi.
W odległości 100 km 3 duże lotniska: Katowice, Kraków, Ostrawa. Dojedziemy do Katowic szybkimi trasami i autostradami, jak również znajdziemy tutaj szeroką bazę noclegową, a tereny wystawiennicze okalają parkingi. Podczas ostatniej edycji targów gościliśmy ponad 350 wystawców i odwiedziło nas 30 000 zwiedzających, w tym delegacja z całego świata.
Jako organizatorzy wspólnie słuchamy i dopasowujemy się, by stworzyć idealny klimat spotkań do rozmów o kierunku rozwoju tej strategicznej branży. Rozmowy toczą się na płaszczyźnie krajowej i międzynarodowej. Organizator targów gości delegacje zagraniczne dzięki współpracy z miastem Katowice i Izbą Gospodarczą.
Tych wszystkich, którzy się jeszcze nie zdecydowali, zapraszamy na Międzynarodowe Targi Górnictwa, Przemysłu Energetycznego i Hutniczego Katowice 2021
oraz Międzynarodowe Targi Energetyczne B2 Energy Poland.
Spotkajmy się na targach od 7 do 10 września 2021. Katowice. Miasto przyjazne biznesowi.
Sytuacja na rynku pracy w sektorze górniczym jest i będzie bardzo zmienna. Dzieje się tak z przyczyn niezależnych zarówno od pracodawcy, jak i pracowników. Zmiany, którym górnictwo podlega, wymagają od osób w nim zatrudnionych lub poszukujących tam pracy nieustającego podnoszenia lub nabywania nowych kwalifikacji.
Spółka JFW Szkolenie i Górnictwo opracowała pilotażowy projekt górniczej aktywizacji zawodowej. Dzięki temu dajemy szansę górnikom, jak również mieszkańcom Śląska utrzymania miejsc pracy w górnictwie. Szansą jest edukacja, czyli podniesienie lub nabywanie nowych kwalifikacji zawodowych w górnictwie.
Projekt Górnicza Aktywizacja Zawodowa GAZ finansowany w całości ze środków Europejskiego Funduszu Społecznego przeznaczony jest dla osób, mieszkańców województwa śląskiego, pracowników bądź byłych pracowników jednostek organizacyjnych spółek węglowych lub przedsiębiorstw z nimi kooperujących. Projekt przeznaczony jest dla osób zagrożonych zwolnieniem, przewidzianych do zwolnienia bądź już zwolnionych. Projekt pozwala podnieść swoje kompetencje oraz kwalifikacje zawodowe, zyskać nowe atuty niezbędne na współczesnym, dynamicznie zmieniającym się rynku pracy.
Projekt Górnicza Aktywizacja Zawodowa GAZ to nie tylko kursy zawodowe służące podnoszeniu lub zmianie kwalifikacji. Spółka JSW Szkolenie i Górnictwo wspólnie z Akademią Górniczo-Hutniczą z Krakowa przygotowały też studia podyplomowe.
Jednym z ważniejszych elementów projektu Górnicza Aktywacja Zawodowa są studia podyplomowe, które będą prowadzone w Akademii Górniczo-Hutniczej w Krakowie. Uważam, że projekt jest ważny i potrzebny społecznie, dlatego zachęcam do udziału w nim.
Szczegóły na stronie www.jswsig.pl. Projekt Górnicza Aktywizacja Zawodowa GAZ.
Here I am in the heart of our Nord product range. Nord Drive Systems manufactures a very large range of drive technology products. Gear units, electric motors, electronic drive technology and industrial gear units. The overall portfolio is a unique modular system from which individual solutions can be created for our customers. Our most well-known drive systems consist of a motor and a gear unit, the geared motor. Our drive systems can also be extended by frequency inverters. Here we have a decentralized solution, also available as control cabinet version. The most complex systems can be seen here. They are used for higher torques or powers. Nord has therefore developed the Max Drive Industrial Gear Unit series, including various integrable components. The almost infinite combinations allow for a drive that perfectly matches the requirements. Let me show you an example. This drive system, consisting of industrial gear unit, electric motor and fluid coupling, is mounted on a swing base. You can also choose an IEC motor attachment, use B5, B14 flanges on the output side, mount a modular external backstop installation, and choose many more product options. Here is another example, a typical application, a belt conveyor drive. Consisting of electric motor, coupling solution, industrial gear unit with axial fan for achieving maximum thermal limit powers, mounted on a swing base. Realized from our modular system. Here is a typical application, a mixer drive, consisting of agitator flange, max drive industrial gear unit, IEC adapter for fitting a Nord electric motor, and a decentralized frequency inverter from Nord, vertically mounted from the modular system. And we also have the perfect drive system for you.
In production industries, there is a rising demand for reliable systems to monitor plant condition. Nord has recognized this need and produces predictive maintenance solutions to increase availability and make it easier to plan service and maintenance. Nord modular industrial gear units are available in 11 sizes with powers of up to 4,000 kilowatts and torques of up to 250 kilonewton meters. In our application test area, we demonstrate the opportunities of digitalization for gear unit operation and maintenance. On a test bed, operating states are simulated by two interconnected industrial gear units. The gear units are equipped with sensors for speed measurement, temperature monitoring and intelligent vibration analysis. Among other things, this shows how unscheduled downtimes can be avoided, availability of plant and machinery can be increased, and their value can be preserved. Sensors record the necessary basic data for the Nord cloud solution. For example, they monitor vibration or temperature. Integration of other sensors such as oil level monitoring is also possible. Via the frequency inverter, the data are available for power and torque analysis. The data are processed by the frequency inverter with an integrated PLC or are sent directly to a gateway. Via the gateway, the data are then sent to the cloud so that they are available for evaluation and analysis from anywhere in the world. To avoid unnecessary data traffic, the local intelligence ensures that data are only sent if their values have changed. The logged and analyzed data are available in a web interface. During a learning phase, the reference state is first recorded. Information from databases for the individual components is used for this. The operating state is compared with the reference state in real time using intelligent algorithms. This enables precise conclusions about the state of the monitored gear unit components, such as gears and bearings, in each stage. Warnings are automatically sent to the cloud if abnormalities are detected. This enables optimum planning of servicing and ensures the availability of the plant. This means that a deterioration can be detected before damage is caused. The application test area also demonstrates the added value of modern data analysis, even in plants without predictive maintenance. Alarm thresholds for faults can be set up to shut down the plant in case of an alarm. Detailed analysis of the data enables in-depth examination of the damage symptoms. The frequency analysis enables conclusions about the part which is causing the measurement change. Therefore, faults such as bearing damage or gear wear can be identified and localized. Predictive maintenance provides great added value for plant operators. Availability is increased. Maintenance costs are reduced and servicing can be planned more efficiently.
Nord Drive Systems has expanded its industrial gear unit product portfolio with a new product line. This gear unit can be especially effective for belt drives used in all areas of bulk handling. We are talking about the MaxDrive XT. XT means extended thermal capacity. As indicated by the name, this gear unit has an exceptional property. Compared with many other drives of comparable size, it has a significantly improved thermal limit power. That means very high drive powers without additional cooling can be used with this gear unit. Especially for the bulk material handling industry, this is a great advantage. The exceptional high thermal limit power is achieved by different devices. A heavily ribbed housing with a surface increased by the factor 2.5, a high efficiency axial fan, and a CFD-optimized airflow with a corresponding baffle design. The area with the strongest heat generation on the drive shaft is hereby optimally cooled. A CFD analysis demonstrates the strong cooling effect and the optimized airflow, especially in the drive area. Compared to the MaxDrive gear unit, this results in a considerably increased thermal limit power. MaxDrive XT also follows the Nord concept of one-piece housings. This structural principle achieves more accurate axis positions, and the gear unit is more torsionally rigid. This results in significantly higher operational reliability and less maintenance. These unique properties perfectly qualify our new MaxDrive XT for belt conveyor drives. For these applications, Nord offers complete drive units consisting of gear, motor, coupling, brake and swing arm, individually tailored to the customer. This is the optimal solution for drives in mixing and agitation processes, optimized with leading companies from the sector for the sector. To illustrate the differences, let me show you which elements are not required anymore compared to the classic version. Wear-prone and therefore maintenance-intensive seals belong to the past, just like the bulky oil tank. Let's have a closer look at the new concept. Here we have a drive system consisting of gear unit, IEC or NEMA adapter and electric motor. And this adapter makes the difference. We call it SOFOMI, sealless adapter for mixers. Compared with the old solution with an oil tank, the oil level can be significantly reduced and is approximately here. The lubricant heats up during operation and the volume increases. Thanks to the new solution, drive shaft seals can be omitted. When the lubricant heats up, the volume of the adapter can therefore be used to compensate. For you, this means excellent operational reliability, compact and simple design, fewer wearing parts, improved thermal properties, and hence less maintenance. SOFOMI, always the first choice for new installations and with easy retrofitting.
Technologia VR, a więc rzeczywistości wirtualnej, jest narzędziem przyszłości edukacyjnej z powodzeniem wykorzystywanym już od dłuższego czasu w programach szkoleniowych spółki JSW Szkolenie i Górnictwo. Tamtejszy system VR jest tak skonfigurowany, iż może być rozbudowany o nowe komponenty edukacyjne. Najnowszym są fantomy, które współpracują z technologią VR, otwierając zupełnie nowe możliwości szkoleń z zakresu pierwszej pomocy przedmedycznej, a więc wiedzy i umiejętności, które mogą zdecydować o ludzkim życiu i zdrowiu.
Wykorzystywanie technik stricte praktycznych do nauki tak ważnej dziedziny, jaką jest niesienie pierwszej pomocy przedmedycznej w zakładzie pracy, tutaj w tym przypadku jakim jest kopalnia oczywiście, jest bardzo ważne. Wiedza teoretyczna, znajomości podstawy zachowania się w pierwszym etapie jest bardzo ważne, ale praktykę, ćwiczenie tego właśnie z wykorzystaniem aplikacji VR, z wykorzystaniem fantomów, prawidłowe uciski, prawidłowe sprawdzanie oddechu. Jest to najważniejszy element i stąd właśnie pomysł w Spółce Szkolenie i Górnictwo, aby rozpocząć szkolenia wśród kadr, którzy mają świadczyć tą pierwszą pomoc przedmedyczną, tak zwani sanitariusze, aby ich poziom wiedzy właśnie z zakresu praktyki, bo teorię mają, jak najbardziej właśnie z nich wykrzesać i sprawić, aby gdy dojdzie do niesienia pomocy, ona była jak najbardziej skuteczna.
Fantomy z aplikacjami VR pozwalają na indywidualny tryb szkolenia praktycznego, które jest dostosowane do umiejętności i predyspozycji każdego kursanta. Wirtualny instruktor precyzyjnie kontroluje czynności ratownicze podejmowane przez uczestnika szkolenia. Aplikacja jest tak zaprojektowana, aby podpowiadać kursantowi właściwy sposób postępowania z korekcją błędów do momentu prawidłowego wykonania czynności ratowniczej.
Na tyle będą wypracowane powtórzenia, aby nabrać tego prawidłowego zachowania. Także wykorzystanie właśnie aplikacji w tym zakresie, stricte udzielania pierwszej pomocy jest najlepszą teraz formą szkolenia moim zdaniem.
Fantomy z aplikacją VR służą nie tylko do praktycznej nauki resuscytacji krążeniowo-oddechowej, czyli sztucznego oddychania i masażu serca, ale także prawidłowego korzystania z defibrylatorów.
Jak go prawidłowo elektrody rozmieścić, jakie po kolei czynności wykonać, aby jeżeli będzie konieczność użyć tego defibrylatora.
Zalety wirtualnego systemu nauki pierwszej pomocy doceniają także kursanci.
Właśnie jestem po skończonym szkoleniu VR. Jestem zaskoczony możliwościami tego projektu. Aplikacja daje mnóstwo możliwości rozwoju umiejętności praktycznych.
Spółka JSW Szkolenie i Górnictwo już teraz zaprasza wszystkich zainteresowanych zdobyciem wiedzy i umiejętności z zakresu pierwszej pomocy na bezpłatne zajęcia, które w ramach Dni Otwartych zaplanowano na czerwiec tego roku.
Good morning, ladies and gentlemen. Welcome very cordially to the second day of the International Conference, the 21st International Conference, Scientific and Technical Conference, KOMEKO-IMTech 2021. Ladies and gentlemen, this is the 21st conference, so the conference with a long tradition. However, this year It's been conducted in a different formula, the online formula. Yesterday we have attracted in front of screens more than 700 persons. So we are very happy to see such a great interest and popularity of our conference. Ladies and gentlemen, the organizers of the conference are the KOMAG Technical Institute, JSW IT System, JSW Mining and Training, and the National Institute for Hydraulics and Pneumatics from Romania, whereas the honorary patrons are the Minister of State Assets, the Marshal of the Silesia region, and the President of the High Mining Office. We are also happy to inform you that the media patronage has been covered by the monthly napędy sterowanie, drives and control, and the newspaper Kruszywa and the mining machines quarterly. Thank you very much. Whereas the sponsors that I'd like to also thank very much include FAMUR PTG, IDEA Pro and Nord. Ladies and gentlemen, today we will continue the innovative issues, topics for the industry supporting the environment. Today we'll be hearing 15 presentations divided into 3 topical sessions. The session on energy management, green energy, another session will be on the safety of operation in mining, and on the innovative and safe solutions for the mining industry. In a moment we will start the first session on energy management and green energy, during which in 5 presentations you will have the following topics: the consumption of electricity by the processing plants, electromobility, the solutions that support environment protection, ability to apply the fuel cells in the mining industry. So please listen to the presentation and send your questions to our email address. One more thing we'd like to mention. Yesterday we received very warm and cordial wishes from the United States, so we are being watched all over the world. So please enjoy the second day of the conference. Thank you very much.
Technologia VR, a więc rzeczywistości wirtualnej, jest narzędziem przyszłości edukacyjnej z powodzeniem wykorzystywanym już od dłuższego czasu w programach szkoleniowych spółki JSW Szkolenie i Górnictwo. Tamtejszy system VR jest tak skonfigurowany, iż może być rozbudowany o nowe komponenty edukacyjne. Najnowszym są fantomy, które współpracują z technologią VR, otwierając zupełnie nowe możliwości szkoleń z zakresu pierwszej pomocy przedmedycznej, a więc wiedzy i umiejętności, które mogą zdecydować o ludzkim życiu i zdrowiu.
Wykorzystywanie technik stricte praktycznych do nauki tak ważnej dziedziny, jaką jest niesienie pierwszej pomocy, pomocy przedmedycznej w zakładzie pracy, tutaj w tym przypadku jakim jest kopalnia oczywiście, jest bardzo ważne. Wiedza teoretyczna, znajomości podstawy zachowania się w pierwszym etapie jest bardzo ważne, ale praktykę, ćwiczenie tego właśnie z wykorzystaniem aplikacji VR, z wykorzystaniem fantomów, prawidłowe uciski, prawidłowe sprawdzanie oddechu. Jest to najważniejszy element i stąd właśnie pomysł w Spółce Szkolenie i Górnictwo, aby rozpocząć szkolenia wśród kadr, którzy mają świadczyć tą pierwszą pomoc przedmedyczną, tak zwani sanitariusze, aby ich poziom wiedzy właśnie z zakresu praktyki, bo teorię mają, jak najbardziej właśnie z nich wykrzesać i sprawić, aby gdy dojdzie do niesienia pomocy, ona była jak najbardziej skuteczna.
Fantomy z aplikacjami VR pozwalają na indywidualny tryb szkolenia praktycznego, które jest dostosowane do umiejętności i predyspozycji każdego kursanta. Wirtualny instruktor precyzyjnie kontroluje czynności ratownicze podejmowane przez uczestnika szkolenia. Aplikacja jest tak zaprojektowana, aby podpowiadać kursantowi właściwy sposób postępowania z korekcją błędów do momentu prawidłowego wykonania czynności ratowniczej.
Na tyle będą wypracowane powtórzenia, aby nabrać tego prawidłowego zachowania. Także wykorzystanie właśnie aplikacji w tym zakresie, stricte udzielania pierwszej pomocy jest najlepszą teraz formą szkolenia moim zdaniem.
Fantomy z aplikacją VR służą nie tylko do praktycznej nauki resuscytacji krążeniowo-oddechowej, czyli sztucznego oddychania i masażu serca, ale także prawidłowego korzystania z defibrylatorów.
Jak go prawidłowo elektrody rozmieścić, jakie po kolei czynności wykonać, aby jeżeli będzie konieczność użyć tego defibrylatora.
Zalety wirtualnego systemu nauki pierwszej pomocy doceniają także kursanci.
Właśnie jestem po skończonym szkoleniu VR. Jestem zaskoczony możliwościami tego projektu. Aplikacja daje mnóstwo możliwości rozwoju umiejętności praktycznych.
Spółka JSW Szkolenie i Górnictwo już teraz zaprasza wszystkich zainteresowanych zdobyciem wiedzy i umiejętności z zakresu pierwszej pomocy na bezpłatne zajęcia, które w ramach Dni Otwartych zaplanowano na czerwiec tego roku.
This is the 18th edition of the International Fair of Mining, combining 350 exhibitors from 12 countries, 26,000 square meters of space.
Please join us on the stage.
Zero, zero, 152.
Good morning, ladies and gentlemen. My name is Grzegorz Strzelec. I am working for the mechanical coal processing unit at the management board office of JSW company. My daily life, I'm monitoring the process taking place in the coal processing plants of our coal mines. Today I'll have an opportunity to present to you a presentation that provides the analysis of electricity consumption by the coal processing units in the period from 2010 till 2020. The analysis covers the processing plants of the coal mines Borynia, Zofiówka, Budryk and Szczygowice, and as well as the mechanical processing unit located at the Knurów-Szczygowice coal mine. The source data has been assumed to be the reported monthly reporting G072 after the coal mechanical processing. The analysis excluded the non-operational today coal mechanical processing sites at Jastrzębska and Krupnicki coal mines. That's all as far as introduction is concerned. So I'd like to invite you to listen to the presentation of the analysis of the consumption of electricity by the coal processing plants at JSW company in successive months in the period from 2010 till 2020. For each processing plant, two slides have been prepared. The first one shows the consumption of electricity versus the net coal production output and the waste output. Those two amounts show you the total amount. So the the output going for processing. The second graph will show the consumption of electricity per ton of net coal production. Noticeable on both graphs, the variability of electricity consumption is due to the variable production output, so the coal extraction output grows depending upon the variable changing conditions, geological and mining conditions of the extraction. The first slide shows the analysis of the consumption of electricity at the Borynia coal mine processing plant. As I mentioned, the graph shows three values. Yellow color shows the net coal production, coal output. The gray color, the waste production output. The red curve shows the electricity consumption during this period. For the Borynia processing plant, the lowest electricity consumption was recorded in 2013 when it was 18.4 gigawatt hours. The highest electricity consumption was recorded this year, last year, when it was 25.2 gigawatt hours. Throughout the entire period under review, the Borynia processing plant consumed 245.4 gigawatt hours for coal production, which represents 16.7% share in the total electricity consumption of all processing plants during the period under review. The second slide shows the analysis of electricity consumption per ton of production, per net ton of production. One can see quite strong volatility of the consumption and a slightly growing trend, upward trend of this value. The average consumption of electricity during this period under review was 12.7 kilowatt hours per ton of net coal output. The second slide shows the analysis of electricity consumption at the Zofiówka coal mine coal processing site. For this plant, the lowest consumption was recorded in 2016 when it amounted to 26.1 gigawatt hours. The highest electricity consumption during this period was recorded in 2011 when it came in at 32.1 gigawatt hours. Throughout the entire period under review, the Zofiówka processing plant consumed for coal processing 318.5 of gigawatt hours, which represents 21.7% of all the electricity consumption of all processing units during the reported period. Despite the takeover from the mid-2017, the output from the Jastrzębska coal mine, the electricity consumption did not significantly increase, while at the same time the quantity of coal processed, coal separated, was higher, and it was maintained at a similar level, which as shown on the next slide. So the analysis of electricity consumption per net output and a noticeable downward trend for this value, while at the same stabilization of electricity consumption from 2018. The average electricity consumption in the period under review came in at 13.3 kilowatt hours per ton of net coal production output. The next slide shows the analysis of electricity consumption at the Pneumatyki coal mine processing unit. The lowest electricity consumption was recorded in 2011 when it came in at 23.1 gigawatt hours. The highest electricity consumption was recorded in 2018 and 2019 when the electricity consumption per annum was roughly 39 gigawatt hours. Throughout the period under review, the Pneumatyki coal mine processing plant consumed 401.8 gigawatt hours, which accounts for as much as 27.4% of the total consumption of electricity by all operating processing plants during the period under review. The consumption of electricity has been stable, which is shown on the next slide. You can see a slight but still significant decline of this value. Average electricity consumption during the period under review came in at 12.2 kilowatt hours per ton of net coal production output. And let us move to the slide prepared for the Budryk coal mine processing plant. The lowest electricity consumption was recorded in 2012 when it came in at 21.1 gigawatt hours. Starting from 2014, the consumption of electricity was fluctuating around 25 gigawatt hours. During the entire period under review, the Budryk coal mine processing plant consumed 268.1 gigawatt hours for coal production, which represents 18.3% share in the total electricity consumption of all coal processing plants during the period under review. Electricity consumption has been relatively stable, relatively flat, as shown on the next slide. So the analysis of electricity consumption per ton production of coal production output. You can see an upward trend in the volatility of this value due to the change of the profile of the production of the processing plant. I mean here the increase of the energy yield from the coking gas and the decreasing share of the production of thermal coals. The average electricity consumption during the period under review came in at 8.2 kilowatt hours per ton of net coal production output. Time to move on to the next coal mine. Now let's move on to the slide prepared for the processing plants of Knurów-Szczygłowice coal mine that have been included in the structure of JSW companies since August 2014. The Knurów coal mine processing plant, the lowest electricity consumption was 2016 when it came in at 14.3 gigawatt hours, and the highest one was recorded last year, 16.3 gigawatt hours. Throughout the period under review, the Knurów processing plant consumed for electricity production 99.2 gigawatt hours, which represents 6.8% of the share in the total electricity consumption of all processing sites in the period under review. The consumption of electricity has been relatively stable, relatively flat, as shown on the next slide. So the analysis of electricity consumption per ton of net coal production output. You can see very slight volatility. The average consumption of electricity during the period under review came in at 7.6 kilowatt hours per ton of net coal production output. The Szczygłowice coal mine processing plant, the lowest electricity consumption was recorded in 2015 when it reached 16.9 gigawatt hours, whereas the highest one was recorded in 2018 when it came in at 23.4 gigawatt hours. During the period under review, the processing plant consumed for coal production 134.6 gigawatt hours, which represents 9.2% share in the total electricity consumption of all processing plants during the period under review. The electricity consumption has been relatively stable, flat, which is shown as displayed on the next slide. One can see a noticeable downward trend with regarding the volatility of this value. The average electricity consumption during the period under review came in at 11.3 kilowatt hours per ton of net coal production output. The final three slides show the summary data for the individual coal processing plants against the background of the entire JSW company. In total, the processing plants consumed about 1.5 terawatt hours of electricity consumption, separating the output that's brought to the surface from underground. You can clearly see the entrance of Knurów-Szczygłowice coal mine very well into the structure and the increase of net production, coal production and waste production output, and a noticeable increase in electricity consumption as well, starting from that moment. Consumption of electricity per ton of net production by the processing sites throughout JSW USA was on average 11 kilowatt hours per ton, stabilizing in the period starting from 2016 until now between 10 and 12 kilowatt hours per ton of net production output, with a noticeable slight downward trend that can be observed. And the final slide showing the summary numbers of the data that was presented. It is probable that the electricity consumption will go up due to be observed growing share of contamination in the output and the planned increase in the yield in the production of coking coal, which is based on the planned more detailed separation of coal and more waste being generated. This process can be observed on the example of currently upgraded processing plants of Budry, Knurów and Szczygłowice processing coal mines. Thank you very much for your attention. Ladies and gentlemen, the topic of my presentation is to determination of the possibility of implementing fuel cells to power the machines and devices used in the process of production of mineral raw materials. That presentation was prepared based on the grant, the preliminary grant. The presentation agenda, definition of the fuel cell concept, presentation of the currently used fuel cells, defining the possibilities for applying fuel cells in the underground workings, and presentation of the potential application of fuel cells in the extraction industry. A fuel cell is a cell that enables generating electricity that comes out of a reaction of oxidation of a constantly supplied fuel from outside. The operation of fuel is based on the synthesis of water by way of electrochemical burning of hydrogen. In practice, it's a reverse reaction to the water electrolysis. On the slide you can see the diagram how the fuel cell operates and the reactions that are taking place on the anode and the cathode. Currently used fuel cells can be divided among others into two groups: the directly fed with pure hydrogen fuel cells and cells that use hydrogen as fuel in various compounds. The purely fed fuel cells include the most popular fuel cells, the PEM type, alkalic fuel cells AFC, fuel cells with the phosphoric acid, with the oxide SOFC, and the fuel cells with MCFC. The remaining have fuel cells fed directly by methanol or ethanol, microbiological fuel cell, carbon fuel cells, and the fuel cells powered by the formic or fed by the formic acid. In order to select the criteria for the possibility of applying fuel cells in the underground workings, the following division was made for the underground workings potentially threatened by the explosion of methane or the coal dust, or the workings that are potentially not posing the risk of explosion. We focus on the ability to apply in the workings that have a risk of a potential explosion according to the following criteria: maximum temperature of operation, availability of the fuel applied, and threats related to the storage and distribution of the fuels, and the threats related to the work, the operation. The temperature of operation of the fuel cells depends upon the losses that arise as a result of reaction. Due to the temperature, the cells can be split into low temperature, medium temperature, and the high temperature fuel cells. On this drawing, we are showing the operating ranges of the fuel cells. The maximum temperature of the operation of the fuel cell should not exceed 150 centigrades because it enables reducing the cost related to the cooling system to be applied. It leads to increasing of the comfort of operation due to the minimizing the emission of heat and eliminating the possibility of heating up the elements of enclosure up to the temperature exceeding 150 centigrades in the space that are subject to potential explosion. After having reviewed the currently applied fuel cells, it's possible to apply only the low temperature fuel cells. The temperature criteria is met by the following ones: microbiological fuel cells directly fed with ethanol, fuel cells of the PEM type, and fuel cells fed directly with methanol. Another criteria for the use of the fuel cells in the underground workings is the availability of fuel. Currently, the most popular fuel is pure hydrogen. It is due, first of all, due to the total lack of emissions and harmful flue gases during the operation. Hydrogen is not available in nature in pure form, but only in the compounds, in the water molecule, for instance. The total annual production hydrogen is 1 million tons per annum, which represents 14% of the total European output of this element. In the majority of cases, the byproduct is the carbon dioxide. In Poland, there's only 12 stations that enable refueling of hydrogen, located around 5 cities. Lack of infrastructure is undoubtedly a factor that limits the ability to use hydrogen as fuel. Methanol is currently commonly used in various industries, among others. In chemical industry, pharmaceutical industry, the plastics production, fuel industry, energy industry, pyrotechnical industry, as well as the shipyard industry. High accessibility and ease of storage of this fuel make methanol an alternative for hydrogen. Ethanol, so the ethyl alcohol, is another alternative that enables feeding the fuel cells. Ethanol is currently produced in large quantities from biomass in the process of renewable, such as sugarcane, grains, or even straw. Ethanol is an attractive fuel because the growing of plants absorbs a majority of the carbon dioxide that is developed during the production. Ethanol is liquid normally and makes it easy to store and transport. Ethanol is the most currently available fuel now because it's commonly used in the food industry as alcoholic beverages. Production of ethanol is relatively simple, and the industrial production capacity means that the price is low. Another criterion is the criterion related to the storage and refueling. Hydrogen as gas is dangerous. In the gas form is 7.5 times more flammable than methanol, due to the very low density, specific density. The storage in normal conditions will lead to the low density of energy accumulated. In order to increase the energy density, the hydrogen is compressed, but the energy required to compress hydrogen are very high. You can now go to 7 bar pressure, but the quantity of gas stored is equal only to 12% of the mass of the tank. For instance, in Rai, there are 2 tanks that are used for hydrogen with total capacity of 122 liters. In the car, the similar tanks were used to the ones shown on the slide. Methanol should be stored in accordance with the local applicable regulations. A sample tank with methanol to be used for fueling fuel cells is shown on the slide. The tanks should be marked with appropriate pictograms in order to provide information about the hazards related to the inappropriate use of methanol. The advantage of this fuel is the fact that in normal storage conditions and use conditions, there are no dangerous reactions taking place. Ethanol is currently the most popular of fuels presented because there's storage and distribution infrastructure in place. In comparison to methanol, ethanol is much less toxic. Versus hydrogen, it's easier to store and transport. On the slide you can see the tank for storing bioethanol that is used as a fuel for the so-called bio fireplaces. The next criterion is the criterion related to the hazard related to work, to operation. Normally hydrogen is colorless, no smell, no taste gas. A mixture can even get ignited even in 20 centigrades. As this concentration of 4 to 75%. 18 to 65% concentration gives a very highly explosion-prone mixture. On this graph you can see the flammability conditions of various substances. Methanol in normal conditions is a normal liquid with a smell and taste close to ethanol. Methyl alcohol is produced only for industrial purposes. Methanol are easily flammable and highly toxic. The vapors of methanol create mixtures, highly explosive mixtures. Deadly dose is between 30 and 100 milliliters. On the slide you can see the information that's provided on the methanol tanks. Ethanol in the room temperature is an easily flammable liquid with certain flavor and distinction. Ethanol is an intoxicating agent. The vapors create a explosion-prone mixture with air. Tanks that are exposed to fire or high temperature can explode. On the slide you can see a tank, an ethanol container that is used for as a disinfectant, surface disinfectant. Having reviewed the currently available solutions, the proposal is that in the underground mining workings the fuel cell should be used directly fed with methanol because it's easy to store and distribute. Ethanol is easily available, commonly available, and relatively safe versus other fuels. The next part of my presentation, I will present the potential use cases for the fuel cells in the mining industry. The first option for application is the direct feeding via fuel cells, the mobile vehicles with electrical drive. Sample application is the powering of engines of underground railway lines. You don't have to use catenary, you don't have to use any charging, and it's relatively friendly for the environment, this type of application. Another potential use case would be the powering of feeding of low capacity, low power consumers. The energy is used to power remote control lamps and sensors, such small consumers. You can also implement the Internet of Things in practice assumptions in the coal mines and distributed sensor network and communications. The advantage of this kind of solution is a lack of a need to recharge those devices and to replace the batteries. Fuel cells can also work in the hybrid setups along with the energy storage system. A sample solution where you can use a hybrid system would be the charger for directly using the devices. The battery is being used. The devices are fed with a module of batteries, whereas the fuel cells perform the function of a charger. Such a solution is cheaper because you can apply the fuel cells of lower capacity, lower power, and you also limit the heat dissipated related to the losses arising during the reactions taking place within the fuel cell. Fuel cells can be used also in the system of balancing the cells. The fuel cells are included in the balancing of the batteries by charging the least efficient, the least productive battery cells, which effectively increases the life cycle of the entire battery, that enables the balancing during the operation of the device and doesn't lead to the reduction of the total voltage of the battery. This solution is quite an innovation, not only in the mining industry, but also in overall industry. To sum up, the fuel cells is undoubtedly the technology of the future because in practice it combines the advantages of diesel drives and the electric drives, battery drives. Fuel cells are almost emission-free because the byproduct is only water and heat. The alternative fuels for hydrogen include methanol and ethanol because they enable simplicity of transportation and storage. The greater growing interest in the fuel cells and the polarization of such solutions will contribute to the reduction of the cost of installation, having reviewed the current state of knowledge, the biggest potential for the applications in the mining industry have the cells fed directly by ethanol. Thank you very much for your attention. Good morning, ladies and gentlemen. My name is Mariusz Woszczyński. I'd like to invite you to enjoy my presentation on the lessons of the efficiency, energy efficiency, with the aspect of applying the photovoltaic installations on the industrial buildings, on the example of the KOMAG Mining Technology Institute. The presentation is based on the work that we performed at KOMAG in 2020. The compilation includes the visualization of photovoltaic panels, selection of the optimum locations, proposal of locating them, layout proposal, initial selection of the sub-assemblies, and focus of electricity production, taking into account the analysis of shadow areas. The work was performed using the software for designing the photovoltaic system BV. So the software enables preparing the detailed photovoltaic designs. The most important feature is the work with 3D visualization. This way we can analyze the shadow areas in the installation. This enables the more detailed simulations of energy yields. Thanks to the rich database, we can find the right solutions, inverters, optimizers, power optimizers, and prepare the diagrams of installation. After entering the data, the performer performs the yield simulation, presented again in the form of tables and graphs, and generates dedicated materials. Designing small home installations for the PV forms starts with planning the demand based on historical data, and then you size the installation to the need. In case of industrial facilities, the energy consumption is much higher. It is important that you use the available area and surface based on the observation of the roofs of the buildings at various seasons of the year, and there was an initial selection of roofs on which it's justified to build such. These are the roofs of the building A. On some of the part of the roof, a 10 kilowatt for 2 years system had in place. The research facility building, the side office buildings, and the Łużycka Street building. On the other roofs, it was not possible to place the PV installations, mainly due to their staying in the shadow or having chimneys installed there or roof windows. Starting with designing using the PV software, first you need to generate the building, the shapes of the buildings, photogrammetric data, and the measurements performed using the Google Earth tool enabled us to generate the individual buildings, including the infrastructure that's in place on the roofs. That was a very tough part of work because there are certain limitations, constraints in the PV solar software, and additionally you need to give certain features of the surface on which the PV panels are to be placed. And it's very important to have the appropriate orientation of the buildings and their mutual positioning against one another, because the modeling was based on the piece of map. As I mentioned, it's very important to provide the right orientation of the building, especially versus the southern direction and the inclination of the panel surface to the level. In Poland, the inclination angle is between 20 and 50 degrees, which is used based on the aluminium support structure orientation. The inclination angle has a direct impact upon the capacity of installation, the productivity of installation. In case the roof is not oriented towards the south, installation will not be effective. But it's a wrong assumption. Looking at the table, of course, in case of a southern orientation, the yields will be 100% of capacity of the installation, but you can see that a 30-degree inclination from the south will lead to the loss of yields, not more than 1%. According to the measurements, the buildings at KOMEK are 37 degrees away, deviated from the southern axis towards the west. Due to this deviation, the questions were arising: what will be the differences when you place the panels in the southern direction and parallel to the edge of the roof? The comparison shows that the first option would be not justifiable in case of parallel construction, or you can build 1 kilowatt bigger installation in the first case, and the payback period is almost the same, whereas in the second case you get the higher yield of productivity of it that describes the quality of a PV system. Another step, except for modeling the building, is planning the layout of the panels on the roofs. At this stage, you have to follow certain important rules related to the fire safety, but as well as functionality of installation. You cannot deteriorate the functions performed by the firewalls on the algal walls, structure walls. You must keep the appropriate distances of the panels from the edge of the roof in order to ensure appropriate maintenance and support services. The structures cannot hinder access to the existing roof infrastructure. You have to integrate with thunder protection installation, and you cannot have a bad impression on the aesthetics of a building. The distance between the rows of panels is of key importance in terms of proper operation. The panels cannot generate shadow for one another. You perform calculation going to do this formula when you have inclination incidence angle of 22nd of December, when the sun is lowest above the horizon. When you take into account the assumptions made, the layout of the individual buildings was proposed. The layout of modules on the slide takes into account also the shadows generated by the infrastructure, roof infrastructure, and the adjacent buildings. Case of building 8, the middle of the longer part of the roof is excluded due to the GSM antenna providing the shadow. On the other buildings, it's the chimney and the superstructure. 30 kilowatt PV panels were placed. The surface of the side building will be used only half of it due to the shadow from the office building. Besides, on the roof there are numerous facilities such as air conditioners, compressors and chimneys that limit the area. 54 PV modules were 18 kilowatt power. The roof of the next side building can be used to a large degree. The shadow area can be caused only by the chimneys and the small antenna. In this case, 104 PV modules were placed with a total power of 35 kilowatts. And now the building that was subject to a review was the research hall. The best use case was here because there are no shadow generating places except for the ladder and the firewalls. 78 module, 26.6 kilowatt. The last building, the office building from the Wojcicka Street, there is a number of chimneys and the GSM antenna on the building. Nevertheless, you can place a PV system with 52 modules, about 18.5 kilowatt power. Having placed the PV panels, you need to proceed on to select the inverters. You perform it based on the calculation of the SM power ratio. In case of Polish installations, the assumption is that the SM should be within 80 and 125% range. In this analysis, we made an assumption that SM should be close to 100%. An important part of the project is the selection of the appropriate gauges of the wires of the cables. You perform calculations according to these formulas as shown, assuming that maximum loss in the cable should not be more than 1%. You should also remember the resistance of cable to mechanical fault, UV radiation or temperature, and the life cycle, which should be minimum 20 years. The final element of the design is the protection. 66367 standard specifies that. The most important assumptions is the placing the surge arresters at the panels and in front of inverters if the distance between them is more than 10 meters. The use of GPV circuit breaking of parallel connecting of more than two string to one NPD input in the inverter. You need to disconnect the DC side from the inverter, but the contemporary inverters have built-in circuit breakers that you don't need to install additional ones. The parallel connecting of strings and the user SPD circuit breakers requires an additional junction box to be used. In case of the AC side, you need to apply double SPD protections if the distance of the inverter to the switchgear is more than 10 meters. For security reasons, you need to apply the circuit breakers, current circuit breakers that are corresponding with the rated power to the inverters. The software generates the diagram according to the data input and the configuration. From the left hand side you can see the strings of PV panels. When the protections on the panels, on the inverters on the AC side you have the protections on the inverters and the protections of the switchgear. You also have designations of wiring. On the right hand side you have a key with the designations of individual symbols based on the selected components. The cost calculation was developed based on the May 2020 wholesale prices. Due to the high popularity of PV, the components sub-assemblies prices are dropping about 15% per annum. The total price that you have to pay in May for components to build the total power of almost 150 kilovolts was 600,000. You have to add to the installation costs that could reach about 10% of the hardware price. Before the potential commencement of the project, you need to get an expert's opinion with respect to the strength of the roof structures. The main factor is based on the load generated by the structure. As you shown in this table, you also have to the snow that could sit on the, due to the inclined support structure, you have to use the formula presented and take into account in what zone of snowfall the given PV installation will be located. All the other works earlier before modeling of the buildings, place layout of the panels and the shadow analysis enable to perform the simulation of the operation of the PV system. In the tables you can see the data of installation, the estimated total energy yields per annum and the financial data. The total cost of investment, which is close to 670,000 per annum, will be paid back in the 10th year of operation of installation. The subsequent years will generate significant benefits, generating about 900,000 PLN after another 11 years of operation. The benefits could be even higher because the life cycle of the panels is to be more than 25 years. The warranties provided by the manufacturers talk about the 80% of the nominal yield productivity after 20 years of operation. The analysis completed shows the energy derived from the PV installations will cover 13.6% of the demand of KOMAG for electricity due to the nature of the operations of the Institute and the profile of its consumption. The in-house consumption will be more than 98%. The cost of the investment project, about 670,000 PLN, will be paid back after 10 years of the operation of installation, whereas this period could be short, and thanks to obtaining financing, funding from the support systems for this type of investment before starting the investment project, you need to pick up the expert's opinion on the increasing the load of the roofing structures due to the additional equipment. Thank you very much for your attention. Ladies and gentlemen, the topic of my presentation is the impact of the balancing system on the durability and security of operation of lithium cells in the selected mining solution. The lithium where batteries appeared in the beginning of 19th and they became very widespread. There are different versions of lithium batteries are available, and their popularity is growing because they are used commonly in smartphones, tablets, cameras, electric tools, aviation, as well as mining. And they start to push out the lead acid batteries that have been for years due to the problems related to the air ventilation of the mining of the workings leads to the current tendencies to limit the diesel machines now in the deepest, and when mining the coal faces, the diesel drives are used as of less early, and the electrical machines are more common due to the need to perform the operation of the mining at the lowest and lowest levels, and with the rock masses the temperature increases by 40%. The operation becomes more and more difficult, and the boundary conditions even possible. The increased temperature of environmental operation does not have not only the security of the performance of the crews, but also the higher failure rate of installed machines and devices, especially those for which lithium batteries are used. The key problem is to protect against the fault, especially in the areas where there is those machines that the lithium batteries are used for powering. The protection must be provided in such a way that the situation doesn't happen where, as a result of the fault, the light is decomposing, where the increase of the gas pressures can be inside, and then it can lead to the ignition and the gas ejection or even to an explosion, which means that as far as possible you have to prevent the decomposition during the operation of cells, making sure that they are used only within the safe temperature, current and operation range. The most often used are the lithium iron phosphate cells, lithium ion, lithium polymer, lithium titanium, manganum, lithium air and lithium graphene. The lithium cells have benefits and disadvantages. The high density of energy, ability to charge and discharge with large currents, broad range of temperature, lack of aeration, lack of temperature adjustment of charging voltage, lack of capacity drop, minimum self-discharging disadvantages, the supervision by the BMS system that's required, or the fuel control system sensitivity to the overcharging and excessive discharging, and the price. Frequent reasons for the failures of the lithium cells during operation: lack of a system controlling and supervising the operation of the batteries, high temperature, operational temperature above the admitted by the producer, contamination inside the cells, storing the cells in bad conditions, overcharging the cells, excessive discharging of cells, and the installation errors. In order for the lithium batteries to operate as long as possible and safe, they are equipped with electronic panels that supervise the operation and switch them off when there are dangerous conditions. Usually specialized electronic systems are used for that are defined by the acronym BMS, Battery Management System, that prevents the fault of battery as a result of an overcharging, overheating or undercharging. Besides, the BMS can measure the level of charging, check the compliance of characteristics and operational conditions, and balance them in order to increase their productivity. This is a necessary action because the individual cells, even provided by the same producer, can vary by the maximum level of the maximum discharging capacity, impedance, and the temperature characteristics. It results in the different level of charge level, which affects the total capacity of fuel and ability of the system to operate further. The balancing method can be split into three main groups. Balancing by the selection, battery selection, that involves selecting based on the physical, chemical, the passive methods that involves dissipating the excessive energy into heat via resistors, and the active methods, active fuel balancing, cell balancing, which involves balancing of the external system that is used for active transfer of energy between cells. The active methods can be used in the majority of lithium group batteries. There are a number of active balancing of cells, and they are due to the flow of energy. They can be brought in five categories: the shunting of cell, cell to cell, cell to battery, battery to cell, and cell to battery and the cell. For testing, we selected the headway cell with 10 ampere hours. It was lithium iron phosphate. The minimum voltage for discharging 2.5, the maximum voltage 365, the operating range with charging from 0 to plus 45%, but for discharging from between minus 20 to plus 65 centigrades. On the cell, we placed 5 temperature sensors glued to the surface of the cell. The 6th sensor was placed next to the tested cell and is used for measuring the ambient temperature. The cell was fully charged and placed in the climate chamber in order to ideally model and map the operating conditions similar to the impact upon the temperature of the tested cell. The simulation of conditions enables avoiding not only the necessary cost during the design phase, but also the excessive losses due to the damage or faults of cells used. Constant humidity 75% was assured during the various plus positive temperature 5, 20, 45 and 60 centigrades, and the same loading current, charging current, 40 ampere. The results obtained were presented on the slide. It indicates that in the normal operation of the cells, when the minimum and maximum voltage as shown by the producers, the temperature doesn't go up too much on the enclosure, despite the different temperatures set in the climate chamber. Next, The tests were conducted of the active BMS system placed in the climate chamber. For this reason, this purpose, the metering system with the Ethernet internet used for accurate measurements of voltage. Two batteries were built of 8 cells, and different methods of active balancing were used. The first one, a cell to battery method was used when the energy is transferred from the most highest charged cell to the entire battery. The other one was battery to cell, where you transfer energy from the entire battery to the weakest cell. Tests in the climate chamber were performed for the positive temperature, which is 5, 20, 45 and 60 centigrade, and the constant humidity of 75%. The tests were aimed at testing what impact on the temperature of the operation of the lithium cells the different environmental conditions have. During the test, one cell was discharged to the minimum limit value provided by the producer, and the balancing of all the cells within the battery set. Based on the test, the result is that with normal operation of the lithium batteries, when the values of the maximum minimum voltage are in line with the ones provided by the producer, the temperature on the enclosure of the cell doesn't go up significantly, despite different temperatures set in the ambient temperature in the climate chamber. The characteristics show how the time of operation changes for the lithium battery depending upon the BMS system used. The most beneficial should be the active balancing the battery to cell system, because it kept the voltage longest above the minimum on the being discharged cell. This is beneficial for the user because it extends the operation of the battery without the need to stop to hold the operation for the charging time. The test also showed that the main threat related to the exceeding of the permitted temperature provided by the producer for the lithium cells during the normal operations by different temperatures set in a climate chamber did not occur. As part of further works, the test will be performed on the actual facilities, so PCA1 suspended the transportation system, battery to cell system BMS will be used. To summarize, for the batteries built of lithium cells, the main threat is exceeding the temperature provided by the producer. Excessive discharging or excessive can lead to the increasing of a permitted temperature. Operation of your cells in various temperatures in the climate chamber did not have a major impact upon the temperature of the tested cell. A battery set made of lithium iron phosphate cell should be supervised using the BMS system or another control system. An active balancing system allows full use of the entire energy accumulated. The battery should not be discharged, should be frequently charged, and you don't have to allow it. And the most beneficial solution should be the BMS system with active balancing of a battery to cell, which keeps the longest the voltage above the minimum voltage for the battery being discharged. Thank you for your attention. Ladies and gentlemen, my name is Bartosz Polnik. I represent the Institute of Mining Technology KOMAG, and I have the pleasure to present to you a paper on development of electromobility in mining as one of the methods for improving the working conditions in the mining industry. As you realize very well, working in the mining industry is very hard, and the conditions there are not easy. This is impacted not only by the issues related to the work underground itself, where the rock mass has its temperature, there's a certain humidity in the air, there's also a lack of sun, but also the devices and machines operating underground. In this presentation, I would like to focus on the operating work conditions stemming from the machines and equipment operated underground. I will focus on the machines that are powered with diesel engines, diesel motors. As an example, in the coal mine undergrounds, for transportation of people and materials, there are suspended rail systems or floor rail systems used. We have also machines on wheels, machines that are used in the ore mines. Usually these are the machines that perform heavy work, for instance, the loading, drilling, loading of explosive materials on the coal face, but also transportation of persons where the different vehicles carry miners to the place where they work. Apart from the suspended floor railway vehicles, we also, and on tires, we also have the track vehicles, both in the hard coal mines as well as ore mines. To show you the problem of working in the vicinity of those machines, a brief statistics. It is estimated that in the coal mines, hard coal mines, about 800 units of machines with diesel motors are used. If we look at the ore mines, such as the KGHM, the copper mines, there are about 1,600 units of those machines. All those machines have an impact upon the labor conditions. First of all, due to the contamination, pollution that they generate, such as flue gases that they emit to the atmosphere. But not only, apart from the flue gas that's emitted by these emissions of those machines, you have to look at the temperature which is due to the operation of diesel-powered vehicles. High temperature generates discomfort and threat, a risk for the crews working in the vicinity. Also noise. Diesel motors, diesel engines generate a high noise factor, so generate potential danger, hazard for the arising of this dangerous situation. One should also remember that in the underground areas, the work is performed at the depth now of more than 1,300 meters. There are problems with ventilation. The temperature already there, inherent temperature there of the rock mass goes as high as 50 centigrades. Therefore, adding more further aspects such as temperature of a diesel motor, additional contamination, pollutions from the emissions of toxic substances or noise, add only more risk, more threats to the natural risks and threats that are already there in place inherently. Of course, appropriate standards, applicable standards, directives and the regulations of the European Parliament mandate the manufacturers of diesel motors fulfillment of more and more rigorous standards regarding the emissions of flue gases, as shown here, the level of carbon oxide, hydrocarbons, NOxes and particles is getting smaller and smaller with each standard. Today we have a standard stage 5, which are very restrictive already, but still the emissions are still there nevertheless and will continue to be there, to be generated. The temperature and noise accompany the emissions as well. In order to counteract this situation, a number of years ago already, the electric solutions were used. The electromobility was born in mining, namely the machines powered with their own energy source, driven by the electric motors, both in case of a floor or suspended transportation system in the hard coal mining, as well as in the copper company, as well as the vehicles on tires used mainly in the ore mines. Both solutions were already equipped with the batteries. The first solutions of this type were provided by the batteries. The solution well known for many years, namely the lead cells in various configurations. This type of a battery allowed the machines to operate without emissions of toxic flue gases, exhausts at a much lower temperature and practically at a minimum noise level. Nevertheless, very quickly, as the drive system and the recuperation options for energy recuperation were possible, the emissions of toxic exhausts were replaced with the emissions, among others, of hydrogen sulfide and first of all hydrogen. Hydrogen, which represents another hazard, which as we know is an explosion prone gas. Therefore, works were conducted to find a different source of electricity. Such works, among others, were performed by the KOMAG Mining Institute. Using lithium as the energy media, practically 30 years ago, the first batteries appeared that enabled emission-free driving of consumers, powering of consumers. Of course, the electronics were the first field where they were used, either in video cameras, in cameras and laptops, and quite recently in mobile phones. However, before this type of solutions was introduced in the mining industry, a number of years had passed and a lot of tests were performed here, a lot of research, and here the KOMAG Mining Technology Institute is the leading force. As time went by, the lithium solutions became so advanced that they enabled their use in the mining industries of today. The most popular solutions are the lithium polymer solutions, lithium iron phosphate solutions, and lithium titanium solutions, batteries. As shown here, it could be in the pocket, prismatic, or cylindrical versions, configurations. What is common for all the solutions is, first of all, the tightness and lack of emissions of any gases, of course, during normal operation. If we look at the advantages of the lithium cells, so we have, first of all, lack of aeration. Furthermore, a broad range of operating temperature, which is very important with levels underground getting lower and lower, deeper and deeper. High energy density enables accumulating sufficient amount of energy within a relatively small volume of batteries. Ability to charge and uncharge with high currents is a big advantage for such batteries, because more and more often we need to charge and charge. We have short time, but we need to fast charge a given battery. With respect to the limitations, because we also have constraints in case of lithium batteries and cells, this is first of all the economics. Good quality cells to be used for industrial purpose have their price, which is high. However, from the user point of view, there are two more constraints. If you wanted to fully utilize the options for fast charging of a battery, you need to modernize electric grids, which generally is not prepared to transmit current with such high current. From a safety point of view, one thing is necessary to be taken into account. The lithium cells are sensitive to overcharging. As you can see, overcharging a lithium cell can end in a self-ignition or even explosion, but due to the chemical agents that are included there, its fires are very showy. And nevertheless, despite such dangers and hazards and constraints, the KOMAG Technology Institute decided to develop a first worldwide solution of railway, underground railway, dedicated railway transportation system to be used in the hard coal mines, a suspended monorail system powered with lithium batteries. This is the GAT-1 transportation system, a large machine used for transportation of sections of support systems for liquidating or tooling of a coal face or long wall, as well as transporting people or transporting other heavy materials. The solutions built using 8 electrical motors with permanent magnets that constitute 4 power systems, powered with a set of batteries composed of 4 internal batteries, each battery powered and independently one drive system, propulsion system. Via the frequency inverters, the battery was transferring the energy to the motors and to the other electrical components that required power. Why the migration to electromobility could be important is shown also on this picture. The transportation of people in the underground areas of a mine is taking place via certain cabins of this kind of transportation beams. These are open space designs where, in case of a diesel engine powered machines, the miner is moving from point A to point B are traveling practically in the cloud of pollution from the diesel engines exhaust. In these solutions we use the lithium polymer cells. These were the first lithium cells with high energy density and first of all high capacity, fully tight, hermetic, airtight, and available on the market and recurring, repeatable. They were supplied with additional management system, supervision system that monitored the thermal uncharging, discharging, level of charging, and the longevity, durability parameters, other valuable information that were responsible for the security, safety of the operation of that machine. And this machine was manufactured along with our industrial partner, certified, tested, and put into operation, commissioned. It was operated in many mines, coal mines, and has been used in the underground areas until today. In parallel to that machine, works were commenced on a smaller solution, a shunting vehicle, and this way the battery vehicle PCA-1 was developed. It's a small, only 5 kilowatt hours of energy is accumulated in that vehicle, shunting vehicle that's used as an auxiliary vehicle for coal-face operations, mining, a lot of work, or the workshop where you used to be done by manual labor or by other machines. This type of vehicles were used to do it before, where diesel motors, the operation of a diesel motor machines was such that the operator was going parallel to such a vehicle and is controlling with remote control such a vehicle. Similar as in case of a large machine, in the vicinity of that machine there were a lot of exhaust. Definitely the migration to electromobility definitely reduced the emissions of exhaust, of flue gases, and reduced the noise and improved the temperature. So improved generally the comfort of conditions of the operating this machine by an operator. There is one feature of that machine that differs in terms of battery. It makes it different versus the GAT1 vehicle, because we use the lithium iron phosphate cells here, because based on the number of research performed at our institute regarding the safety of operating the lithium cells, we gained knowledge this type of technology is safer than the lithium polymer technology. It also became more available, more widespread than it had been before. Based on that battery, we built the entire set of batteries in the PCA-1 vehicle, and we introduced a novelty here by integrating the charging and discharging system. In this solution, a user doesn't have to apply a separate charger, because the charger is already integrated with the inverter. So after discharging, the user simply approaches a sample transformer station, connects with a cable, and charges the battery. The time of charging, depending upon the availability of the connection, it could be half an hour up to the maximum 3 hours. The vehicle was put into tests, was already operating by several coal mines, and the acceptance is very positive. The personnel is happy because they are dealing with a machine that's not emitting any pollution. It's not noisy while operating, also doesn't emit, just generate high temperature. Besides the hard coal mines, we also conducted works related to electromobility underground areas in the ore mines. The institute was approached, the KOMAG Institute was approached by KGHM Zana with a problem of exhaust emissions, flue gas emissions, and introduction of in the self-propelled mining vehicles. For instance, the WS-150, such vehicles are used for placing the explosive devices into the openings, holes in the coal face, drilled openings. So far, this action was performed in a way as shown on this picture, where the given person was placing in a blind coal face, purely ventilated, was placing the explosives, but the powering of that could have been done via the electric wire from the coal mine power supply system or from the diesel engine being operated in the vicinity. Usually, not to waste time, the diesel engines, diesel motors were used by the miners. Please imagine how in such a deep, with such an area, poor ventilation, what operating conditions were there for labor conditions for this miner. We took up the challenge, solving a number of difficult issues, and this way we built this WS-172 vehicle. And this battery-powered, self-propelled vehicle, we again use the lithium iron phosphate cells that 32 kilowatt hours we were able to put together in those batteries. Also in this case, the battery was charged using the charger. We have here an option to use two solutions. WS-172 was equipped with a separate charger, however 173 and 173 were based on the integrated solution. Similar in the case of the PCA vehicle, it's possible to approach the given point, come to the approach, and you don't have to use an independent charger. The machine was put into operation practically in December 2017. A few months of tests, and starting from 2013, it's been normally operated. As of today, there are about 30 units already manufactured that are successfully placed in the underground areas of the coal mine. On the picture that we can see here, we can see the module of the batteries and the charging module. This is the example of this 172, where the request of the customer, the charger was an independent element. What's important, the user's satisfaction with this machine was underlined repeatedly in a number of media publications, and here's a quotation where it is written that the WS vehicle is operating in the Polkowice-Sierowice ore mine since February 16, 2018. One charge of the battery enables operating the machine for 2.5 shifts roughly. So 2.5 shifts in quote-unquote comfortable conditions as far as they can be achieved in the underground ore mine. With respect to the tracked-based vehicles, the last project that was implemented by the KOMAG Institute was applicable to the track-based machine. It was the floor loader, so the machine used for operating to be used on the coal face, depending upon the tool placed on its arm, and also for maintaining the appropriate condition of the floor of the longwall heading in the coal mine. They were either powered with electrical or self-propelled or the wiring. We have developed a solution that's zero emission, purely battery-based, also lithium iron phosphate batteries-based, integrated with the charger. The entire project, as I mentioned, was based on the lithium iron phosphate cells. The battery was built, installed, mounted on the machine, and the machine, with the participation of a manufacturer, was developed and underwent a number of tests. The benefit, the advantage of this machine versus the previous solutions designed by our institute is the fact that we are dealing here with a two-source electricity power supply, which means that the machine can operate practically for 24 hours a day. The battery that enables operating for roughly 3 hours. After getting discharged, the machine is connected to the coal mine power supply system, and you can operate it using this power supply. At the same time, charging in the meantime the battery. Thanks to separating these systems when selecting the mode of operation from the power supply network, the user can, for 24 hours a day, operate the machine. Having charged the battery, again, we disconnect the power supply line, the charging line, and the machine 100% mobile again, without being tethered to the line, to power supply source. This machine received a number of awards. Unfortunately, the epidemiological situation that occurred last year hindered definitely the ability to implement this machine. But we do have hopes, along with the manufacturer, that this year we'll be able to put into operation in the underground areas of the mines. Ladies and gentlemen, to summarize, one should remember that the electromobility significantly improves the labor conditions We have a total lack of emissions of toxic flue gases exhaust, significantly reduced level of generated noise, and a significantly reduced level of generated temperature. Additionally, thanks to the energy recuperation capabilities, you extend the time of operating on a single charge. With respect to the ease of energy replenishment in comparison to the diesel-powered machines, it's much simpler, much less expensive. You needed appropriate fueling tanks. They had to be maintained. They posed a hazard. You just need to have access here to the power supply network of KOMAG in the explosion-prone areas. You can safely carry out this process. So finally, I'd like to present several letters from the mines that were operating this type of solutions, what they paid attention to. First of all, to the clear improvement of the labor conditions and the lack of emission of hydrogen, which was applicable in case of the acid-lead-based batteries. Finally, I wanted to show you what is a big constraint, the financial data, short analysis of the cost of operating a GAT1 vehicle versus the diesel vehicle with a similar capacity and power, showed that practically the operation of a GAT1 vehicle represents 30% of the cost of operating a diesel vehicle, of the maintenance, operating conditions, ongoing costs. This example shows that if you invest higher funds, larger funds in purchasing such a device, such a machine, will generate a quick payback through a reduction in the operating expenses. Ladies and gentlemen, thank you very much for your attention. I'd like to invite you to cooperation, and please remember, industrial electromobility is the KOMAG Institute. Please start cooperation. Ladies and gentlemen, we have completed the first session of the second day of the 21st International Conference, Technical Conference KOMEKO-IMTech. You had an opportunity to listen to 5 interesting presentations regarding green energy and energy management. We have heard how the electricity consumption is shaped at the coal processing plants, what problems the users of such plants face, and what are the directions that are being implemented in order to reduce electricity consumption. For that reason, we had a chance to listen to the presentations on the renewable energy source abilities to use PV panels, what are the advantages, what are the limitations, constraints regarding the selection of the PV panels. Furthermore, we were able to listen to a presentation on electromobility in the mining industry, where examples were given of development of this type of transportation system in the underground areas of the mines. The constraints were pointed out related to the use of such solutions. Also, tests were shown on various systems for managing energy in this type of solution, but also the directions for development, for evolution, were outlined to the future possibilities for applying fuel cells in the underground areas of mines. Thank you very much for your activity during the first session. For the questions sent, also remember about further KOMEKO at komag.eu address that you can send questions to. Now we are facing the second session today, will be related to the safety of work in mining, operation in mining. Both technical aspects as well as legal aspects will be presented related to this topic. Ladies and gentlemen, also the examples of best practices will be presented. I think will be used not only for exchange of experience, but also the discussion, mutual discussion that will be generated. So, ladies and gentlemen, I would like also to remind you that each presentation is being interpreted on the parallel YouTube channel, and the last of the presentations regarding to the whole sensor application will be also interpreted from the original English version into Polish. So please enjoy. Thank you very much.
Technologia VR, a więc rzeczywistości wirtualnej, jest narzędziem przyszłości edukacyjnej z powodzeniem wykorzystywanym już od dłuższego czasu w programach szkoleniowych spółki JSW Szkolenie i Górnictwo. Tamtejszy system VR jest tak skonfigurowany, iż może być rozbudowany o nowe komponenty edukacyjne. Najnowszym są fantomy, które współpracują z technologią VR, otwierając zupełnie nowe możliwości szkoleń z zakresu pierwszej pomocy przedmedycznej, a więc wiedzy i umiejętności, które mogą zdecydować o ludzkim życiu i zdrowiu.
Wykorzystywanie technik stricte praktycznych do nauki tak ważnej dziedziny, jaką jest niesienie pierwszej pomocy, pomocy przedmedycznej w zakładzie pracy, tutaj w tym przypadku jakim jest kopalnia oczywiście, jest bardzo ważne. Wiedza teoretyczna, znajomości podstawy zachowania się w pierwszym etapie jest bardzo ważne, ale praktykę, ćwiczenie tego właśnie z wykorzystaniem aplikacji VR, z wykorzystaniem fantomów, prawidłowe uciski, prawidłowe sprawdzanie oddechu. Jest to najważniejszy element i stąd właśnie pomysł w Spółce Szkolenie i Górnictwo, aby rozpocząć szkolenia wśród kadr, którzy mają świadczyć tą pierwszą pomoc przedmedyczną, tak zwani sanitariusze, aby ich poziom wiedzy właśnie z zakresu praktyki, bo teorię mają, jak najbardziej właśnie z nich wykrzesać i sprawić, aby gdy dojdzie do niesienia pomocy, ona była jak najbardziej skuteczna.
Fantomy z aplikacjami VR pozwalają na indywidualny tryb szkolenia praktycznego, które jest dostosowane do umiejętności i predyspozycji każdego kursanta. Wirtualny instruktor precyzyjnie kontroluje czynności ratownicze podejmowane przez uczestnika szkolenia. Aplikacja jest tak zaprojektowana, aby podpowiadać kursantowi właściwy sposób postępowania z korekcją błędów do momentu prawidłowego wykonania czynności ratowniczej.
Na tyle będą wypracowane powtórzenia, aby nabrać tego prawidłowego zachowania. Także wykorzystanie właśnie aplikacji w tym zakresie, stricte udzielania pierwszej pomocy jest najlepszą teraz formą szkolenia moim zdaniem.
Fantomy z aplikacją VR służą nie tylko do praktycznej nauki resuscytacji krążeniowo-oddechowej, czyli sztucznego oddychania i masażu serca, ale także prawidłowego korzystania z defibrylatorów.
Jak go prawidłowo elektrody rozmieścić, jakie po kolei czynności wykonać, aby jeżeli będzie konieczność użyć tego defibrylatora.
Zalety wirtualnego systemu nauki pierwszej pomocy doceniają także kursanci.
Właśnie jestem po skończonym szkoleniu VR. Jestem zaskoczony możliwościami tego projektu. Aplikacja daje mnóstwo możliwości rozwoju umiejętności praktycznych.
Spółka JSW Szkolenie i Górnictwo już teraz zaprasza wszystkich zainteresowanych zdobyciem wiedzy i umiejętności z zakresu pierwszej pomocy na bezpłatne zajęcia, które w ramach Dni Otwartych zaplanowano na czerwiec tego roku.
This is the 18th edition of the International Fair of Mining, combining 350 exhibitors from 12 countries, 26,000 square meters of space.
Please join us on the stage.
Zero, zero, 152.
Województwo śląskie oferuje wiele rozwiązań dla biznesu. Natomiast Międzynarodowe Targi Katowice 2021 to wyjątkowe wydarzenie. Dlaczego warto się tu spotkać?
19. edycja Międzynarodowych Targów Górnictwa, Przemysłu Energetycznego i Hutniczego Katowice 2021 już przed nami. To jedno z największych wydarzeń w Europie i trzecie na świecie. Spotkamy się już między 7 a 10 września 2021 w Polsce, w Katowicach, w Międzynarodowym Centrum Kongresowym oraz na placu przed Spotkiem.
Nadchodząca edycja targów Katowice 2021 została wzbogacona o Międzynarodowe Targi Energetyczne B2 Energy Poland.
Jako organizatorzy przygotowaliśmy dla Państwa ponad 60 000 metrów kwadratowych powierzchni targowej.
Katowice jako serce województwa śląskiego to miasto otwarte na biznes i przyjazne inwestorom. Znajdujące się w nim Międzynarodowe Centrum Kongresowe to wyjątkowy obiekt, który został wyróżniony jako jeden z najlepszych kompleksów do organizacji konferencji, kongresów oraz targów w Polsce.
Oprócz naszych targów, Międzynarodowe Centrum Kongresowe gości również 5. Polski Kongres Górniczy, Europejski Kongres Gospodarczy i wiele innych.
Dla przemysłu istotna jest branża energetyczna i elektryczna, która podczas targów B2 Energy Poland Katowice 2021 ma doskonałą przestrzeń do prezentowania innowacyjnych urządzeń i technologii. Targi o charakterze międzynarodowym to świetna okazja do podjęcia współpracy z międzynarodowymi koncernami energetycznymi i odbiorcami końcowymi.
W odległości 100 km 3 duże lotniska: Katowice, Kraków, Ostrawa. Dojedziemy do Katowic szybkimi trasami i autostradami, jak również znajdziemy tutaj szeroką bazę noclegową, a tereny wystawiennicze okalają parkingi. Podczas ostatniej edycji targów gościliśmy ponad 350 wystawców i odwiedziło nas 30 000 zwiedzających, w tym delegacja z całego świata.
Jako organizatorzy wspólnie słuchamy i dopasowujemy się, by stworzyć idealny klimat spotkań do rozmów o kierunku rozwoju tej strategicznej branży. Rozmowy toczą się na płaszczyźnie krajowej i międzynarodowej. Organizator targów gości delegacje zagraniczne dzięki współpracy z miastem Katowice i Izbą Gospodarczą.
Tych wszystkich, którzy się jeszcze nie zdecydowali, zapraszamy na Międzynarodowe Targi Górnictwa, Przemysłu Energetycznego i Hutniczego Katowice 2021
oraz Międzynarodowe Targi Energetyczne B2 Energy Poland.
Spotkajmy się na targach od 7 do 10 września 2021. Katowice. Miasto przyjazne biznesowi.
One of the areas of the operations of the KOMAG Mining Technology Institute is the operations regarding to the broad understood ensuring of technical safety. These operations are performed by the unit of attestation TESS, the certification unit that carrying out numerous certification processes, compliance assessment, issuing opinions and expertises, contributes to maintaining and improving the technical safety level. In today's presentation, the review of the operations of a certification unit, the competences held, authorizations and were presented, and also how these operations shape or influence, impact the safety, technical safety. The agenda of the presentation, the legal basis of the compliance assessment, ensuring technical safety, areas of the operations of the unit for attestation test of the certification unit, and finally, conclusion, summary. Ensuring technical safety and safe labor conditions is derived directly from the Constitution of the Republic of Poland, which includes the following wording. Everyone has the right to safe and hygienic labor conditions. Article 66, Clause 1. Public authorities protect consumers, users and lessors against the actions threatening their health, privacy and safety and unfair market practices, Article 76. With respect to the products brought to the market, to the trading, understood as making available products on the market for the first time, the following legal acts are applicable. These are two acts: act on the evaluation of the compliance and the act on the systems for assessment of compliance, the act related to the European Union directives and implementing the provisions of those directives into the national legal system, and the act on the general product safety, defining the actions to be taken with respect to the products being brought to the market in case there is a lack of detailed other provisions of the European Union related to the safety thereof. Ensuring technical safety, the basic actions that determine the technical safety of the machines and devices are the following actions. First of all, activities that the manufacturer, producer is responsible for, namely designing and producing, manufacturing the product, taking into account the analysis and evaluation of risk, so that all the unidentified threats could be eliminated, or the risk related thereto could be limited to the acceptable level. Secondly, in order that the sources of danger, of hazards, could be monitored in such a way so that by initiating the preventive actions, the increase of risk could be prevented. And activities that the user is responsible for, namely the use of application of safe labor methods and providing appropriate collective protection equipment and personal protective equipment. KOMAG Mining Technology Institute has within structure a separate organizational unit, this unit being the attestation test unit and certification unit, which has been for a number of years, many dozen years, is participating in the processes of compliance of the products, processes that require participation of a third party that is independent of the manufacturer, producer and the user. The operations of attestation unit and certification unit is focused on evaluating the products at the stage of them being brought to the market, to trading. The features, properties and parameters that determine the safety of products are defined based on the analysis of the documentation, verification of the calculations, inspections and the results of a laboratory test. Credible results of tests carried out at accredited laboratories provide information based on which you can determine if a product is safe. Certificates issued based on the results of tests and any other evaluations or results of tests support the producers in declaring the compliance of the products being manufactured with the applicable essential recommendations of the directives of the European Union and the standards. One should emphasize that the KOMAG Mining Technology Institute has its own accredited laboratories. The testing capabilities enabled carrying out the tests as part of applying the compliance according to the directives in line with the accreditations had. One should note that 3 accredited testing laboratories are part of the structure of a KOMAG that comply with the requirements regarding the competence, impartiality, and the consistent operations of the laboratories. And before that, the certification unit that complies with the requirements regarding the certification of the products, processes, and services included covered by the applicable standard. The scope of accreditation granted by the Polish Accreditation Center covers the certification of the compliance of the products in accordance with requirements of the standards covered with respect to accreditation ACO 23 carried out on the basis of the certification programs of the type I1A, 1B, 3 and 5 according to the applicable standard, as well as the accreditation covers issuing of opinions regarding the products admitted to be used in the mining, in the coal mines, based on pursuant to the Article 113, Clause 3 of the Act, the Geological and Mining Law. The attestation unit is also a notified unit, number 1456. It has accreditation for the procedures for assessing compliance, and the unit has the notification of the European Commission for conducting the compliance assessment modules of the procedures enumerated in Directive 2014/34 EU. This is the ATEX directive, as well as to conduct the type tests EC in accordance with the machinery directive and the toy-related directive. The competence and experience of the personnel, as well as the infrastructure of the attestation unit of the certification unit, allows additionally to conduct activities regarding such areas such as certification of the products according to the program that authorizes one to give warranty guarantee marking B can be granted, and certification of quality management systems according to the standard ISO 9001. The operations of a attestation unit of a certification unit is not limited only to the certification. The unit also performs the evaluation of the competence of the overhaul units, especially with respect to the overhauls of anti-explosion devices, as well as conducts the technical reviews, inspections at the operation site, prepares technical opinions and expertises. To sum up, why should one select the offering of attestation unit of a certification unit? First of all, we have many dozens years of experience and a well-established position on the market. Our own in-house research, back office, own in-house laboratories, accredited laboratories. The unit works with in-house laboratories. Use of a management system that comply with the latest world standards, and both laboratories and the unit apply and has in place implemented the standards regarding the operations conducted. Competent engineering team, trustworthiness, accuracy, and impartiality of evaluation processes carried out was all performed by accreditation of a Polish accreditation center in Warsaw, and the notification for the activities within the area of the ATEX directives related to the machinery and toys. And the most important factor that impacts the established position of our unit is the trust of the customers that leads to commissioning the evaluation processes as both in the mandatory area as well as the voluntary area. Good morning, ladies and gentlemen. We are at the Mining Technology Institute, one of the research halls. We have against the backdrop of testing station for testing half masks. This was part of international project ROCD. My name is Andrzej Dzięgiel. I've been working since 1982 at KOMAG Institute, and I'm a chief specialist for international cooperation. Good morning, my name is Krzysztof Leszak. I'm an employee of a laboratory of the applied tests. Well, together with my colleagues, we built the earlier mentioned workstation, test staging station. That includes the dust chamber, in which we can prepare the environment with the required concentration of dust. Then the climate chamber, where the appropriate humidity and temperature, ambient air is prepared. Thanks to that, when simulating breathing in and breathing out, we can simulate the actual breathing. The dust level in the chamber and outside the half mask tested is tested using the dusting meter with division into different fractions, PM1, PM10, PM0.5, and it's all controlled by the programmable controller and the control panel here. Whereas the role of artificial lungs is performed by the two cylinders powered by a motor. So much for the introduction. Let's start the presentation. We are proceeding to the presentation. We can divide the mask into FFP1, FFP2, FFP3. One stops around 80% of particles, not smaller than half a micron. Number 2 stops about 94 such particles, and number 3 stops almost even 99.95%. The counterpart of FP2 in the American standards are the N95 masks that stop roughly 95% of particles. In terms of China, they have their own standard, according to which the mask is designated as KN95. Both the FFP2 as well as N95 and KN95 are defined as sufficient in the antivirus protection. We, as part of the LCD project, were also dealing with that aspect, taking advantage of the fact that we faced the pandemic in the course of carrying out our project. Below, I'm showing some of the masks that we received from the partners in the project in order to perform tests of efficiency. I would like to very briefly look at this slide and the next slide. If someone is interested, they can go back to that content regarding the recommendations with the use of the half masks, as well as the discussion of the reasons for the ability to filter out. Let's move on to the topic of testing station according to the European standard EN 149. Various testing methods are recommended. However, the basic one is the testing station for clogging of half masks. As you can see it on this diagram, on this testing station, a special chamber, we are testing a mask or a filtering material, and using the compressed air we are feeding dust, dolomite dust, to this chamber within a certain time, and based on that we are evaluating the given mask. The second equally important test is the so-called internal leakage, so the quality of the fitting alignment of the mask to the face. The special station, effort generating station, strain generating with the participation of a human being. Such a mask is being tested in especially under effort, human effort, strain, in order to cause leakage as a result of untightening as a result of intensive breathing. We, as part of the RCD project, we were also dealing with the surveying in order to determine whether surveying is a good method for selecting masks, but with respect to the conclusions, I will come to that later. However, the main issue regarding the main topic of our part of the project was to set up a station for testing the mask. Here's the diagram. The main component of this testing station is the dust chamber, where we are placing the artificial head or the specimen of the tested specimen of the mask. The important section is the climate chamber, environmental chamber, which was to provide the appropriate temperature and humidity of the air that was brought in via the mask, so simulating the breathing. An important part was the artificial lungs combined, made up of two cylinders. One cylinder was sucking in the air from the climate chamber and feeding it to the dust chamber, and the other one was used to suck in the dusted air from the chamber, supplying it to the utilization tank, and when it was sucked in, the DRX dust concentration analyzer, DRX 8533, that we were able to evaluate individual dust fraction from PM1 to PM10. That's you saw the station at the very beginning of the presentation. Let me repeat: the climate chamber, environmental chamber, the dust chamber, the artificial lungs, and the earlier mentioned analyzer. We also carried out the microscopic analysis of used masks that our partners in the project provided to us. These pictures are very give you a lot of information about the efficiency of the use of half masks, and this should impact the awareness level why such masks should be used. Please take note of the fact even if the final internal layer of a mask has clearances where the tiniest dust can get through. However, the majority of the particles of dust is captured by the mask. This graph enables us to compare the filtering capabilities of various masks sent to us by the partners. These are from FFP1, the gray one, from the colleagues from Slovenia that we received, up to FFP2, and FFP3, the blue one. The graph starts from the filtering efficiency of 98.8, so we can say that all the masks tested achieved very good level of filtering, and in terms of the PM10 dust, even only slightly below 100% efficiency. A certain surprise was very good results achieved for the Molbeck's mask. This is the mask sent by our Slovenian friends. Although it was FFP1 mask, for each type of dust, for each fraction, it achieved excellent results. However, one of the masks, FFP3 type masks, unexpectedly had worse results here than the Moldex company mask. This is all these analyses were enabled through this testing station. Let me add that the mask were 100% tight on the artificial head in order to avoid the accusation, the allegation that one mask was better fitted than the other. Of course, we also did tests with loosely placed mask on the artificial head, but due to the time limits, I will not be elaborating on that. Another interesting example experiment is the testing of a specimen of a filter, for example, FFP3, of a filter with a 40 millimeter size picked up from the cutout from the FFP3. You can see that the filtering in an excellent way, but at a certain point in time we opened a certain leak opening 1 millimeter, and then additionally 1.5 millimeter opening, and you can see in case of such small leaks, untightening and openings, the capabilities have reduced. The total surface of the openings was equal to 0.2% of the 40 millimeter surface. A certain surprise was KN95, came from the KN95 mask, which from the very beginning, even when we had both openings plugged, it was displaying the feature that the dust, PM1 type dust particles, was being let through at a similar level, was passing through at a similar level as at the time when we opened two openings for checking. So we can make a conclusion that this mask is not very effective with respect to the KN95 particles. So the antiviral protection, its efficiency, its effectiveness will not be satisfactory. But it's also note that in the chamber we applied the dust concentration of 15 milligrams per cubic meter, and the values after filtering, the maximum values, even with both openings open, reach to the maximum level of 0.4 milligram per cubic meter. Time for conclusions. Ladies and gentlemen, at KOMAG we have the only station in Poland that offers the comprehensive properties of half mask with respect to the filtering, resistance against breathing, and the leaks. I didn't mention before, but in parallel to all those registrations, logging, we can log the resistance of breathing in and breathing out, and also compare the half masks, how they perform regarding that. We draw a conclusion that the good alignment of the mask to the face in the anti-dust protection is equally important as the quality of the filter applied. Even the smallest internal leakage deteriorates significantly the effect of the filtering. Selecting a mask based on the surveys should not be the only method, but it should be an accompanying supplementary method. The gate valves for breathing out in the mask in case of dust protection should be used. They allow for protecting the mask against quick humidification. After the use of a mask in case of high concentration of dusting, it should be disposed of, shouldn't be reused. Half mask should be appropriately selected for the conditions of dusting, and this is how it is done in the coal mines in practice. With respect to, in terms of antiviral protection, the tests of half masks that we performed on the station also allowed us to evaluate, since the recommendation of the FFP2 masks are effective in antiviral protections. And we proved this way that the KN95 popular mask purchase on the Allegro portal, it could have been a copy that just we came across, didn't just have those features, satisfactory properties in this regard, but we were able to evaluate it using our testing station. With respect to the surgical type half mask, those popular blue ones, we can say that due to the demonstrated impact of minor leaks also in antiviral protection will not be effective for those people using it. They'll be more effective for the third parties, not for those directly using it. For respect to the breathing gate valves, one can say that in that antiviral protection they are recommended because the person using such mask will be subjecting the third parties to direct contact with the air, so they're not recommended. They're air breathed out, not filtered. Another comment with respect to the reuse of mask for antiviral protection, we can use it, but after the lapse of 72 hours to 3-day quarantine or seasoning of a mask in order so that viruses that could have set on that could have been neutralized in the meantime. Thank you very much for your attention, and the contact details you can see on the slide, and so please we invite you for cooperation. Ladies and gentlemen, I do hope that the presentation you found the presentation interesting. We would like on our behalf to invite you to cooperation. If you have any needs regarding the testing of masks or proposal related to cooperation regarding this topic, we would like to cordially invite you to cooperation. Thank you. Ladies and gentlemen, my name is Michał Szelka, and I'm an employee of KOMAG Mining Technology Institute. I'm a specialist with respect to the design and structural solutions in the power support systems. I'd like to invite you to listen to my presentation. Ability to apply the dedusting, disinfecting device in order to counteract the harmful environmental factors. Harmful factors at a working station can have a negative impact on the health condition of a human being and its well-being. One of the main factors that have an impact upon the well-being of a human being and his health is the quality of air in the labors at the workstation. The quality of air, apart from temperature, humidity, and pressure, is also affected by various types of pollutions that we can split into chemical, dust type, and biological one. We are showing in the presentation a small size dedusting device with an added module, disinfection module based on the ultraviolet radiation. The additional module is aimed at neutralizing biological contamination that's in the air in the form of so-called biological aerosols that can get into the respiratory act of the system. Bioaerosol, we call the set of biological particles spread in the air or in other gas form. It could include single spores, individual spores, mycelium, mold, bacterial, and the biological materials and spores transported by a larger non-biological particles such as dust. The biological contamination occurring in the air in the form of so-called biological aerosols can play an important role in transferring allergic infections, infectious diseases, or even contribute to an epidemic. In case of the dusting devices, the closed-circuit water circulation is used. The ambient temperature and the high temperature humidity makes the environment very prone to the mold and virus distribution. The agent that is proposed to be used flowing through the dedusting device will have a positive impact upon the quality of air and the health of people working in the vicinity, eliminating all the microbiological and dust originating contamination. Sterilization and disinfection terms are used in parallel, in common, but in practice they describe two different processes. The sterilization is a process as a result of which all kinds of cervical, bacterial, and spores are destroyed, whereas disinfection is a process that is aimed at neutralizing bacteria to a level that is safe for a human being. The sterile condition, due to the existing conditions, could be very difficult to obtain. Furthermore, the achieving of the disinfection, reducing or neutralizing the bacteria to the level that's safe for the human being should have a positive contribution to the labor conditions. Ultraviolet radiation belongs to the electromagnetic radiation, similar as X-rays or light or radio waves. The ultraviolet radiation can be split based on the wavelength. It can be divided for long term between 400 to 350 nanometers that have a least harmful impact upon the human being's organism and increases the pigmentation process of the skin. A long-term contact can develop cataract. Medium wavelength UVB radiation 15 to 280 also induces pigmentation of the skin, but high levels can lead to burns of skin. This type of radiation can be responsible for allergies or cancerous skin cancer. short-term 280 to 100 shortwave length radiation naturally is not available naturally as a result of its absorption by the atmosphere around the planet Earth, similar as UVB causes the skin burns and increases the skin cancer risk, and has the bactericide properties. The bactericide mechanism involves the absorbing of UVC by DNA of the UVC of the virus. As a result of this process, the process of the division of cells is stopped, which is equivalent to the loss of the ability for reproduction. The UVC radiation in particular is harmful for the bacteria and viruses, and to a lesser degree for yeast and mold. In the communication of the main Chief Center Inspector of the 4th of March 2020, we can read the viruses survived surrounded by the thin fat layer that are destroyed by detergent, soap, and the ultraviolet radiation. Initial design of dispersive disaster is based on the disaster is based on the OD400. The upgrade enabled us to simplify significantly the design of a device. Now its structure is based on two modules: the sprinkling chamber, and the drop separator, and the modules were designed as the welded structures protected for anti-corrosion by zinc coating. The mode of operation, the principal operation of the dusting device. The polluted air is sucked into the when it goes to the spraying via the sprinkler nozzles. Water is supplied to the stream. This way, the polluted air goes in contact with water. The water jet goes to the inclined cellular, and when the water comes into intensive contact with the dust, and it's permeating the water drops, and the water jets permeate coming into the area that is part of a secondary dispersion node. Further on the veins of the guide vein, that the air is swirled, the stream and the water jet that includes the water drops that carry the dust particles goes into the drop separator, that as a result of a friction caused by the swirl of the vortex of the main water jet, they are being separated from the air. In case of drop separator filling inside the drop separator, the drop separation process is intensified. The water separated from the air and the dust particles are, including therein, are carried via the ducting, are brought to the tank. In case of a device, the dusting device that's being part of the OD400Z, there's a number of options to apply another module, an additional disinfection module. In case of the first item, the radiators are immersed in the tank, and the water are subjected to disinfection due to the slow velocity of the flow. The solution doesn't require the use of a large number of ultraviolet radiators. The drawback of the solution is the fact that as the time progresses of the operation of the tank, the pollution in terms of sludge will be increasing, what has a negative impact upon the permeation of the liquid by the radiation, ultraviolet radiation. The second point is in the water duct between the tank and the sprinkling nozzle, increased medium to the tank, and the ability of the harmful impact upon the radiator of the small particles flowing through the ducting. Item point 3 is placed in the water spraying chamber between the guiding veins and the radiation. Thanks to this location, the radiation that is harmful for humans is within the enclosed device. In this case, the ultraviolet radiation will have a direct impact upon the air flowing through the dedusting device. Achieving of a disinfected condition using the ultraviolet radiation is easier in case of air than in case of water. In the chamber, drop separation chamber, the purity of air is defined as 99%. An important aspect is such a selection of radiators that in the case of a flow 140 cubic meters per minute, they are able to eliminate at least 90% of the biological contamination. Based on the analysis of the radiators proposed, the Philips company solution was proposed. The battery of radiators with a power of 4 times 150 watts enables operation of the capacity of 10,000 cubic meters per hour in case of the operating range of a dedusting device. 4,800 to 10,800 cubic meters per hour covers the capacity range, particular range of a device. In the radiators, the radiation was used, 254 nanometers wavelengths were used. The use of shorter wavelengths would increase the energy of photons, which would be an advantageous development, but in this case also the bonds between oxygen molecules would be broken and the ozone would be obtained, which is harmful. The set of 4 radiators with a total capacity power of 600 watts will be built between the guiding vanes and the chamber filling, preventing the contact of third parties with the operating device, as well as the radiation getting out of the enclosure. Based on the analysis of standards harmonized with the ATEX directive, the use of ultraviolet radiators in the proposed configuration directly would be impossible. The radiators should be enclosed and protected with a special type of fittings that prevent it from ensure the spark safety and against flammability. There are different enclosures available on the market also for the ultraviolet radiators. Apart from the physical protection, other protection should be applied in the electrical area. The proposed solution of a disinfection of agent flowing through the dedusting device will have a positive impact upon the quality of the air and the health of condition of the people working in the vicinity thereof, limiting contaminations of the dust type and microbiological type. Compact design of the device will enable its easy moving. It will be working very well in case of the processing plants, large indoor facilities, warehouses, and the large scale events of indoor venues where you need with lots of people involving, where you need a high purity of air. Thank you very much for your for listening to my presentation.
Dzień dobry Państwu, nazywam się Grzegorz.
Good morning, ladies and gentlemen. My name is Grzegorz Debita. I'd like to present the state of test on the system for underground rescue systems that, for example, was installed at one of the copper mines. The agenda of the presentation, ladies and gentlemen, is as follows. I will try to cover the structure and the ways of implementing the pilot network for the BPLPSC network at the copper mine. We will briefly discuss how the capacitive couplers, inductive couplers, and modems were installed. I will also speak about the method applied to model the cable routing, the measurements of efficiency of the transmission for the BPL using the both capacitive and inductive couplers, as well as the tests and of the quality of voice for the quality of experience solution. So we have collected appropriate voice samples, audio samples that were tested by the dedicated listeners, and the summary, the conclusions. Ladies and gentlemen, on this slide you can see the structure of a pilot network at one of the copper mines for the 6 kilovolt cables with installation points marked on the drawing. The main text point would be the shaft topped A and B, for which the quality of voice of speech was tested, audio quality was tested, but the installation itself was currently connected in points A, B, C, and D. For the capacitive couplers, ladies and gentlemen, we used the architecture where the coupler was connected only to a single phase of the mining cable, which was the so-called, the modem was the so-called master in this configuration of the architecture of that network. However, we used two modes of transmission. One of them was the mode where directly we were connecting using the capacitive coupling method, but also it turns out that you can receive that signal using the inductive method on the appropriately applicably short distance. For the capacitive couplers, you can see here the installation point 1 of the cable distribution panel. So as you can see here, that was the installation for the phase. And the installation of this coupler was also the installation for the phase at the target point, the so-called target point B at the underground, in the mine. The inductive couplers had to be installed more frequently at shorter distances for such a reason that for the solution that was subjected to measurements, the distance had to be appropriately short so as to be able to carry out any transmission via that system. And so on the surface in point A, the coupler was installed on the entire cable. In point B at the shaft top, another installation was mounted. Then in point C at the shaft bottom practically, and at the D distribution point in the same spot where the capacitive coupler was mounted. Sample installation of the modem was as follows. To the modem, the coupler was connected via the appropriate filter, and to each modem you can connect a device using the Ethernet standard. It could be a computer, a microcomputer, or any device that is using the computer network standards for communications. For the experience purpose, suppression was measured for the 500-meter distance, and a propagation model was calculated for the attenuation and then verified. The current plans and the current initial calculations indicate that we are able to model very precisely the attenuation, the suppression in the mining cables. And also the parameters were measured, quality parameters were measured, objective ones, so the signal-to-noise ratio for the capacitive coupling at a distance of more than 1400 meters, and here the results obtained were at the level of around 13 dB signal-to-noise ratio. For the inductive coupling, we obtained at a distance of around 300 meters in the region of 18 dB. However, the 1100-meter segment here, we had problems obtaining the good parameter because it was around 8-9 dB. Similar situation applied to the so-called C point, the last one. And ladies and gentlemen, now the tests of signal quality were performed at point A and point B, between point A and point B, for the following reason, that unfortunately further on the quality of the transmission was left a lot to be desired. Two types of coupling were tested, inductive, and the mixed, the capacitive and inductive. The transmission was performed in two modes that were able to enforce in the modem, so between 2 and 4 megahertz and 2 to 7 megahertz, designated by the manufacturer respectively mode 1, mode 11. The goal was to define the minimum bit rates in order to transmit understandable voice communication, because it says ultimately it's to be a rescue system. It would be best, it was decided that such messages should be provided at the lowest possible bitrate, not to burden, to overload the connection. The audio signals were coming from the ITU resource according to recommendation P501 for the telecommunication system from 2017. The original samples were available in the waveform, 16-bit, encoded using the PCM coding method, modulation method, and the sampling rate of 32 kilohertz. Additionally, ladies and gentlemen, the audio, the sound samples were available in the 2 sentences spoken by 2 women, 2 men in various languages. For the experimental purpose, we used 3 languages: English, British English, German, and Polish. Each file, in this case, audio file, was encoded using the OGG format for 3 different bit rates: 8, 12, and 8, 16, and 24 bits per second. The listening tests were conducted for the sample group of 15 persons in the age 25 to 35 age, so the typical employee of the company. The tests were performed in accordance with the ITU BS 1284 recommendations, and the evaluation was performed in the 5-degree Mohs scale, the so-called Mohs, were 1 poor quality and 5 excellent quality. In the tests, the so-called fully enclosed overhead, fully over-ear earphones, and the results were for 8, 16, and 24 kilobits per second. For the mode 1 and 11, for the inductive coupling, this is what you can see here, and for the mixed coupling, subsequently you can see the results. To sum up, the lowest 8 kilobit per second turned out to be insufficient, ladies and gentlemen. On the other hand, 16 was not always ensuring unequivocal and understandable voice messages. For both types of couplings tested and the transmission modes, the minimum requirements for the bit rates, the minimum bit rate was determined to be 24 bits per second. Because only for this bit rate, all the speech samples, audio samples, received the evaluation assessment above 4, so above good. At least good. So, moving on, concluding, you can see the clear advantage of a broadband mode, the mode 11 for all types of transmissions. And also you can observe for both types of couplings applied. In the versions, in both variants, the results were very similar. The publications available demonstrate that in case of commercial speech transmission systems, the bitrate requirement is between 48 and 64 kilobits per second, so our solution at this stage has a certain advantage. Further works that we'll try to carry out is testing the target groups, so rescue personnel and soldiers that could use it in case of rock burst systems in our systems, caving system cases, and expanding the network by adding further points and stabilizing physical parameters, attempt to launch the video transmission, attempt to launch a sensor network for the rescue personnel, conducting the quality tests in the subsequent phase for the new codecs, and ultimately developing our own communications node, nomadic node, dedicated for the rescue system. Thank you very much for your attention, and all the best.
Good morning, everybody, ladies and gentlemen. Title of my presentation is on performance of ground fault protection using Hall sensor under real conditions of operation. That's a problem is of great importance, since to the fact that the ground fault create almost 90% of the total faults which are met in the substation. Therefore, a few words of introduction. Then few words on the structure and basic characteristic of the protection being developed. Next, I would like to just present you the network layout and method of testing. A few words of comments. Next, this will be presented selected investigating results, and I will perform the discussion on that. And I have finished with. As everybody knows, in the middle voltage networks, the problem of selective and fast detection, as well as clearing of faults of a small residual current of a ground faults, is of great importance, and so far has not been yet solved satisfactorily. To meet requirements in coal and copper industry, when this problem is of great importance, a new type of ground fault protection with the use of Hall sensor as a measuring device has been developed. The Hall sensors are widely used, and they are available on the market. And therefore, when we developed this protection, first this protection was checked under the lab conditions, and if in the case when the lab testing was fulfilled and was finished, we have thoroughly examined it under having conditions, real conditions of operation in distribution middle voltage, particularly in the mine networks of this selected for 6 kilovolts and 20 kilovolts. Here is indicated the sketch of this protection. It is simplified sketch. It is composed of the current conductor flowing here, current conductor located inside the window of a magnetic core, creating the summation transformer, and inside the core is being developed magnetic flux due to the current flowing in the case of asymmetry. It is zero sequence current, and in the gap of this core is located as a detector Hall sensor, and Hall sensor is just exerted to both to the magnetic field due to the current flowing and by the electric field, which is supplied from the terminal of zero sequence voltage transformers connected in the open delta, and therefore is provided the zero sequence voltage. EPA is a special electronic regulator of the phase displacement, since we are able to regulate the current between the zero sequence current and between zero sequence voltage. It is of great importance for the networks operating with isolated neutral point or for grounded via resistance or via impedance. At the output, we have a measuring converter with an amplified unit, and therefore we measure this value. In a case when the quantity is being measured, I0, zero sequence current, and zero sequence voltage are variable with time. Mostly they are sine wave, indicated sine wave. Output voltage measured at the terminal of a Hall transformer, of a Hall sensor, is being found as it's composed of two components. Constant component, which doesn't depend on time, and the AC components, alternative components, being changed with a double frequency. It depends on time. Therefore, here we have a DC component, and here we have AC components. When C is a phase displacement between U0 and I0, it depends on the conditions of operation of a network. However, C is a real characteristic angle which can be controlled depending by the special phase shifter, and therefore the protection must be adapted to application. Here is indicated the lab results when we employed the voltage, which is zero sequence voltage around 100 volts, and the current being stable about 5 amps, and we changed the angle. And then you can see that we obtained the two characteristics. One is indicated by blue line, is for C with this angle, this angle relay characteristic angle equals 0. Well, so therefore, this protection is specially adapted for the resistance everything neutral point. And then when we have a network with isolated and always compensated neutral point, we have to shift this angle And therefore the RCA must be shifted by 90 degrees, and also you can see this current is, the voltage is also pretty high, is around a little bit less than 8 volts. Therefore this voltage is, this value is sufficient to perform operation. Next, for the given zero sequence voltage, with being changed between portion of volts up to about 100 volts, when we change the current as a stable value, we obtain that the output voltage, of course, depends on the current. It doesn't depend on the voltage area, on the voltage zero, which is advantage, and of course, respectively increase with respective increase of current. And therefore, this value is sufficient to perform operation of this. Next, after finish the testing in the lab conditions, we have prepared this protection for the testing and distribution network, both 6 kilovolts and 20 kilovolts in a strict mine. And I would like to underline that this protection was located not only on the 40 volts, on the 40 feeders, but also on the healthy feeders to perform the operation. We have not modeled, but we have the test, the conditions of operation in different cases of non-effective earthing for uninsulated neutral point, for compensated neutral point, and for compensated with following respective earthing. That's performance is being done especially to provide the active component of earth current to increase sensitivity of commercial ground faults. Then it was also tested for the different types of the faults which can be met in practice for metallic, it means for the stable faults, for the resistive, we change the resistance for which the fault is being modeled in real conditions, and also in the case of existence of arc or without arc for the intermittent, very dangerous for detecting. Here you can see this relationship between the DC components and between the voltage, when the voltage which is employed is a constant, is a full voltage, is 100 volts, and when the current is being changed from transient up to the stable value, up to very low value, much less than 0.5 amps, 0.5 amp. And also you can see that in this case the DC voltage is dropped down for the stable value of current up to around 1 volts, which is also sufficient to perform. For this, in this case, we have found the protection worked properly. We have checked also the performance of operation in a case when we have grounded neutral point VR resistance. Also, when it's isolated and compensated, when it's totally compensated, therefore the reactive components is compensated and active component can be very little. Therefore, it's not able to be detected by the commercial protection with RCA equals 0. Therefore, after some time, usually, this ACF automatic system, automatic components forcing, is being switched on, and immediately current is raised up to the respective value after around 3 seconds, and respectively the voltage which arises on the terminals of Hall sensor is also increased respective value. The next problem is that in practice we have met the facts that the current is very little and the voltages also can be very little, particularly in the case of resistive fault. When resistance, when we have a fault via high resistance, therefore in such a cases zero sequence voltage can be dropped down below the value being set. Usually in practice this value is no smaller than 10 volts. Therefore in this case, as you see, we can see that even the current is around 3 amps. You can see that the voltage is dropped down. And however, what's going on with about our protection? You can see this value of the DC component, and DC components, this is around 1 volts, which is also effective, which is also enough for effective operation. And in this case, we found out that protection was able. Then we compare the performance of a faults of a protection located on the healthy and the faulty phases, and we have found in this case, for example, then when you have a current of around 3.5 amps, and the voltage is about 100 volts. Therefore, as a matter of fact, however, there's a capacitive current. There's a capacitive current. There's a self-capacity of the cable, of the feeder, particularly for the cable. This capacitive current is pretty high. Therefore, however, in this case, the voltage which we measure on the terminals, the DC component, indicate the negative sign. Therefore, this protection, instead to give the information to operate, this give information for blocking. Therefore, that another problem we can face in practice is an operation under asymmetry, under load asymmetry. In a case when we have a very high current, particularly when we provide energy to asynchronous motors with pretty high power, for example 400 kilovolts. In this case, immediately we have at starting up, we have an inrush current, and then, however, the current drop down, but even then, the voltage which is we can measure is enough high, is a little bit below 1 volts. However, still can be significant to perform operation, which is not good things. Therefore, in this case, this protection would operate in a fault way. Therefore, what could we do? In this case, we obligatorily have to apply additional special magnetic screen located inside the window of a magnetic core, which protected. It simply short circuit the flux. However, sensitivity of this protection is being a little bit dropped down, but its selectivity is being increased, and the ratio of selectivity to sensitivity indicate the increase. Therefore, that's performance. At the end, we have a few conclusions that we found out that the Hall sensor, which based directional ground fault protection, can be successfully applied in practice. It was confirmed by both lab investigation and investigation under normal conditions of operation in the mine. Sensitivity was found is being relatively high to detect resistive faults up to about 2.5 kilo ohms. Directional characteristics can be easily adapted to requirement of network conditions. For example, for the network operated with isolated neutral point, with compensated, with resisted, with just also by compensated by resistive earth, and so on. If the requirement is a high sensitivity at the selective point within the network, one has to employ obligatory the additional magnetic screen protected the mal-operation. The residual voltage threshold must be also set above the noise level, which was usually found in the practice around 0.3 volts. Therefore, we have raised up this value of this operation to get sufficient selectivity of operation. As a matter of fact, we have found that this protection developed by us is effective, is sensitive, and is cheap, and it's very easy to employ it, just enough to clamp it over the cable, and it's very simple to just operation. Therefore, thank you very much for your attention.
Ladies and gentlemen, we have just heard the second session of today's presentations, and the presentation as part of a second session were ideally in line with today's challenges and the times of today. Please take note that the second presentation, the efficiency of a half mask in the anti-dust protection, was also related to the antivirus protection, therefore ideally is in line with our today's contemporary challenges, as well as the ability to use of a dedusting device, dedusting and disinfection device. These are the examples of best practices that definitely will be taken advantage of, that provide us a lot of various options to take actions. ladies and gentlemen, what's very important, would like to emphasize today, the poster session was also made available to you, so we'll be able to observe various interesting graphic arts and infographics, and therefore we'd like to invite you to get to know them, to look at them, study them. And after the poster session, we'd like to invite you to the final session of our conference, equally important session related to the topics regarding innovative and safe solutions for the mining. During this session, these sessions will have a chance to listen to 5 interesting presentations where we'll be discussing the topics related to the monitoring the rock mass stresses, topics related to the improvement of efficiency in the mining process, in the either longwall miners, or improving the drilling, boring of headings in the underground. Also an interesting presentation on the new system for advancing the longwall miner operation. Thank you for all the questions, for activity in the previous sessions. I'd like to invite you to further activity and send questions to komag@komag.eu. So please write us.
Technologia VR, a więc rzeczywistości wirtualnej, jest narzędziem przyszłości edukacyjnej z powodzeniem wykorzystywanym już od dłuższego czasu w programach szkoleniowych spółki JSW Szkolenie i Górnictwo. Tamtejszy system VR jest tak skonfigurowany, iż może być rozbudowany o nowe komponenty edukacyjne. Najnowszym są fantomy, które współpracują z technologią VR, otwierając zupełnie nowe możliwości szkoleń z zakresu pierwszej pomocy przedmedycznej, a więc wiedzy i umiejętności, które mogą zdecydować o ludzkim życiu i zdrowiu.
Wykorzystywanie technik stricte praktycznych do nauki tak ważnej dziedziny, jaką jest niesienie pierwszej pomocy, pomocy przedmedycznej w zakładzie pracy, tutaj w tym przypadku jakim jest kopalnia oczywiście, jest bardzo ważne. Wiedza teoretyczna, znajomości podstawy zachowania się w pierwszym etapie jest bardzo ważne, ale praktykę, ćwiczenie tego właśnie z wykorzystaniem aplikacji VR, z wykorzystaniem fantomów, prawidłowe uciski, prawidłowe sprawdzanie oddechu. Jest to najważniejszy element i stąd właśnie pomysł w Spółce Szkolenie i Górnictwo, aby rozpocząć szkolenia wśród kadr, którzy mają świadczyć tą pierwszą pomoc przedmedyczną, tak zwani sanitariusze, aby ich poziom wiedzy właśnie z zakresu praktyki, bo teorię mają, jak najbardziej właśnie z nich wykrzesać i sprawić, aby gdy dojdzie do niesienia pomocy, ona była jak najbardziej skuteczna.
Fantomy z aplikacjami VR pozwalają na indywidualny tryb szkolenia praktycznego, które jest dostosowane do umiejętności i predyspozycji każdego kursanta. Wirtualny instruktor precyzyjnie kontroluje czynności ratownicze podejmowane przez uczestnika szkolenia. Aplikacja jest tak zaprojektowana, aby podpowiadać kursantowi właściwy sposób postępowania z korekcją błędów do momentu prawidłowego wykonania czynności ratowniczej.
Na tyle będą wypracowane powtórzenia, aby nabrać tego prawidłowego zachowania. Także wykorzystanie właśnie aplikacji w tym zakresie, stricte udzielania pierwszej pomocy jest najlepszą teraz formą szkolenia moim zdaniem.
Fantomy z aplikacją VR służą nie tylko do praktycznej nauki resuscytacji krążeniowo-oddechowej, czyli sztucznego oddychania i masażu serca, ale także prawidłowego korzystania z defibrylatorów.
Jak go prawidłowo elektrody rozmieścić, jakie po kolei czynności wykonać, aby jeżeli będzie konieczność użyć tego defibrylatora.
Zalety wirtualnego systemu nauki pierwszej pomocy doceniają także kursanci.
Właśnie jestem po skończonym szkoleniu VR. Jestem zaskoczony możliwościami tego projektu. Aplikacja daje mnóstwo możliwości rozwoju umiejętności praktycznych.
Spółka JSW Szkolenie i Górnictwo już teraz zaprasza wszystkich zainteresowanych zdobyciem wiedzy i umiejętności z zakresu pierwszej pomocy na bezpłatne zajęcia, które w ramach Dni Otwartych zaplanowano na czerwiec tego roku.
This is the 18th edition of the International Fair of Mining, combining 350 exhibitors from 12 countries, 26,000 square meters of space.
Please join us on the stage.
Zero, zero, 152.
Good afternoon, ladies and gentlemen. My name is Jerzy Jagoda. The topic of my presentation will be the presentation of the works implemented as part of a European project under the Coal and Steel Fund with the acronym PRAS-3, P-R-A-S-S-3. The topic will be analysis of the operation of the SSMSC module in the wireless radio network that has been performed at the KWK Pneumatyki coal mine. The SSMS system was designed and implemented in order to monitor the geometry of the shield support monitoring system. The system includes inclinometer, SMSI, installed on the individual sections of the powered support to measure the inclination angle. In case of the Pneumatyki coal mine test, 5 inclinometers were mounted on the floor, on the shield, and 2 inclinometers of the shield point. And the next part of the system is the module for measuring the tip phase path, SMS with an ending S, that measures the distance of the section from the coal face, from the longwall phase. The final part of the system is the central unit, SSMSC, which is connected via cables with the other module via the Modbus RTU bus, picks up data, retrieves data from it, and then it's shown via radio to the superior, to the master network, and the unit is responsible for providing power supply to the individual inclinometers. The two-axis inclinometer SSMSI is provided on this slide. The measuring range is in the individual axis. For the axis minus 60 degrees up to 120 degrees, whereas for the y-axis from minus 90 to plus 90 degrees. The inclinometer communicates with the central unit via the Modbus RTU bus. The inclinometer is equipped with a protection against the dusting and water penetration according to IP65. The device was certified as regards the compliance with the ATEC directive for the M1 zone in the Group 1 with the IA safety protections level. Verification was completed. The certification EU type certificate was issued by J.S. Hamilton Testing Laboratory. The next element of the system is the tip-to-face path measurement module. It has the range of 5 meters. It's powered 2 times 3.6 volt batteries, 17 per hour. It communicates with central units via the Modbus RTU bus. Similar to inclinometer, the tip-to-face path measurement model is compliant with the ITEX directive to work in group first M1 zone, EA protection level, IP65 protection against penetration of water and dust. All the parameters were confirmed by the EU type certificate test performed by the J.S. Hamilton company. The central unit SMSC is equipped with 4 times 3.6 volts with a 17 ampere hours capacity. The device is equipped with a radio system transmission and with a 50 milliwatt power capable to transmit data at the 2.4 gigahertz wavelength. It communicates with the other modules via the Modbus RTU bus. The central unit complies with the same requirements with respect to the compliance with the ITEX directive as the previously presented devices, but is confirmed by the certification regarding the EU compliance. The data from inclinometers and from the tip-to-face measuring module are sent to the central unit and goes to the pressure sensors network. The data from the radio system is synchronized over time and stored on the server for further analysis by the superior level, higher level software. The system developed this way was implemented on the FASOS 1329 at the coal mine in Pneumatyki. It was mounted. The system was mounted on 10 sections. On this drawing, you can see one set of the system, full set of the system, to be installed on a single section of shield support. One central unit, 5 inclinometers, one tip-to-face path measurement module. That's the full set. The pictures show the pictures of the individual elements of the system from the N7 coal face longwall phase at the Pneumatyki coal mine. The elements are mounted on the shield support, powered support system using the magnetic fasteners. You can see the inclinometers and the central unit on the drawing. On the next slide, we are showing the tip-to-face path measurement module. The system was commissioned and the correct logging of the data by the system was confirmed, was proven. The upper graph shows the change of the angle of the shield support system, and on the lower one the changes in the distance from the face of the long wall for the system. Proper operation of the system took place before the first failure happened, which was related to the breaking of the tip-to-face path by the long wall miner. It was crashed, the module, and pulled inclinometers behind it, and they were also destroyed. As a result of the failure, there was no visibility to the data from some components of the system of a single section. The testing process could have been continued anyhow. The next failure prevented further analysis of the measurement data. The reason of failure was the fault of a cable of the antenna system, which resulted in total collapse of the communications of the system. The maintenance persons were sent to the dispatch to the coal mine. They repaired the connection, but despite the repair, the system wasn't sending data anymore. Further trips of the service personnel were necessary, and they managed to restore the system. The system was performing correctly until the next failure happened, which was the reason was the crashing by the miner of the antenna system. The failure was so serious that the decision was taken to dismantle the system. The elements of the system were dismantled and supplied to the ITG KOMAG Institute. During the analysis, it was determined that the central unit SMSC, its battery was excessively discharged, and the files were destroyed on the damage on the SSMD micro on the data. The data recovered from the damaged data card as micro SD. The reason it was shown, the reason excessive discharging of a battery. The software improvements were made that would prevent the excessive discharging of the battery during the registration of the data, recording of the data on the card. After the improvements, the functional tests were conducted at the seat of the Varkop company, which confirmed the proper operation of the system after the repairs or improvements have been made. To sum up, the system was operating in accordance with the design assumptions until the cabling of the antenna system was broken. The failures allowed us to detect and eliminate the deficiencies in the operation of the SSMS system. During the test, excessive discharge or use up of the battery of the central units, the reason were the attempts to store data on the damaged micro SD cards. The storage procedures were modified in order to avoid the excessive discharging of a battery. Thank you very much for your attention and for listening to my presentation. Ladies and gentlemen, at the beginning of any process that is being implemented at a coal mine is simply extracting the fossil. In Polish coal mining, the dominating today system is the long wall powered support system, mostly with a drum-based miners. Small number of other systems are used. Small coal mines also use other mining systems, but their share in the extraction process is very limited, very small. Very often we associate the mining or the efficiency of a long-wall mining with the technology, with the devices installed. And this technology, we get excited by this technology without noticing other factors that also have an impact upon the efficiency. There is a saying by Eric Drucker that the technology is exciting, but it's important to take a step back and understand the context that makes something possible, that something is efficient, effective or not. Ladies and gentlemen, the measurement of the use of the time of the operation of machines and devices that are getting more and more complicated in the miner systems was introduced in the Polish mining sector already back in the 1960s, but during the economic transformation time they were kind of put in the corner, and they were not, and we didn't calculate, we didn't analyze how the time is actually utilized. In practice of measuring the efficiency of industrial processes, you apply the so-called key performance indicators or metrics index. They are called KPI, Key Performance Index, KPI as an acronym. Such an index, such an indicator for mining or extraction within a time limit. So in other words, the productivity indicator is in fact a product of multiplying two parameters, namely the time of operation during the available time and the technical potential of the mining system. We are talking about the comprehensively supported with continuous miners that represent the dominating factor, production element of the Polish coal mining. Such a system includes the miner, the conveyor, scraper conveyor, the so-called armored or flexible, powered support, long wall support, including the crusher, hydraulic aggregate feeding the powered support, a set of electric devices, power supply devices, control devices, and all the other auxiliary aggregates based on the technology. Ladies and gentlemen, as I mentioned, the technical potential is the ability or capability of some technical system to carry out, to perform certain work. Unfortunately, in nature, in the implementation of any process, there are various factors, constraints that, limitations that, restrictions that make the actual mining extraction within a limit time unit is lower. The goal should be to seek to make sure that the actual extraction is as much as possible close to the potential of, for instance, the power support mining system. As I mentioned, the actual extraction is a function of time of operation, and the technical potential of a mining system. In the systems used in the traditional system, the productivity of people was this decisive factor. It is important to take advantage, to utilize the operational time, the working time. It is assumed as the calendar time is assumed to be the base of measurement of. This is the time, day, and hour, which is the highest measurable value. It could be a change, it could be a shift, a year, a day, a week. Reference points could vary. There could be multiple reference points. The second element is the technical, theoretical potential of a mining system, and particular attention should be placed on that, because the total utilization of time and the utilization of its potential, technical potential, capability of a given mining system determine the final outcome of our operations or activities. In this case, the productivity of longwall phase extraction. The measurement of the level of utilization of longwall mining systems is very important, and it's necessary to analyze the measurable parameters, available parameters of the operation of a longwall mining system by measuring some parameters of longwall miner. They include such parameters as the actually performed yield or extraction of longwall miner, measured usually as the ratio of the actual value achieved in practice and the value that is according to the catalogs, according to the data sheets. It's a design parameter. The second element we can measure, especially when we have contemporary advanced diagnostic systems and monitoring systems for monitoring the mining devices operations, just to mention the e-mine or smart pipe systems produced by FAMUR, is the degree of taking advantage of the average advance rate of a miner versus the rated maximum value of that parameter. Practically, based on our observation, that the parameters that I just mentioned usually do not reach the rated, the nominal values, which in fact leads to the reduction of the actual instantaneous yield of mine extraction of a longwall miner versus the value that is described as the rated, the nominal value. Ladies and gentlemen, let us focus on the utilization of a calendar time, because here it seems to us, based on our observation, this is where the reserves are greater. We are seeing an example here from a few years back, but based on our observation, we can say that not much has changed. Namely, this is the sheet of a report where the mining companies that use our miner systems receive for accounting for the periods of operation, either daily, weekly or monthly. If you look here at one element, this is what's the key information from this data sheet. The effective time of operation of a mining system, understood as a time during which the mining system is advancing and is mining. This is the time where the miner is actually extracting coal. Please take a look. The share of this time is only roughly 9.2% of the total available time on the longwall mining. This is just happens to be a monthly report, so there's still a big reserve unused yet. Here we have another example of a report prepared by one of the Polish mining businesses, which is analyzing the availability, dealing with the availability of a longwall mining system and the reasons for which this mining system is not available. The parameters are a bit better here, namely the availability of mining system, longwall mining system, on the individual days is higher. It tops 50%. This is a value that is quite high versus the previous one. But please note that the availability does not cover here, does not show the actual performance, actual work. The fact that the longwall mining system was available, it doesn't mean that it was really mining, extracting coal during all that time. Plus, let's have a look how others do it. This is the structure of operational time for the mining system, longwall phase mining system, prepared by the Australian mining sector. As you can look at this structure, as a matter of fact, the most important time for us is shown here on this diagram, a time highlighted with the green color, this box, because this is the only time that, as a matter of fact, actually in case of a longwall mining system, we are really extracting coal. All the other information, all the other time shown on this diagram is the time that doesn't directly generate coal for us. Therefore, we need to seek to eliminate a large number of those idle times, let's call them, and at the same time, by maximizing at the same time the directly utilized, direct run time. In the diagram shown before, you could see three groups of times: the operational time, the time of organizational breaks. These breaks, pauses should be eliminated. We need to do our best to get rid of them, and the time for repairs and technical maintenance of the devices. Here we should try to seek to reduce the share of this time within a day. But one needs to remember that in order to not to experience failures, we need to give those machines what they are due, namely give them the correct maintenance in terms of support services, ongoing, maybe not repairs, but ongoing activities, maintenance activities that will extend their life cycle and maintain their reliability. And now, talking about a certain philosophy, about a certain idea, the effective time, as I mentioned, is the time when the longwall miner is operating, the miner is extracting coal, the coal is transported, hauled outside of the longwall area, and all the other operations are performed. So we can divide this time into two important groups. The time when the mining system is mining, this is the effective time, and all the undesirable time that's not effective because the miner is not mining, so no mining time. One should try to make sure that the red color highlighted time here should represent the smallest possible part of the calendar time. And now, trying to make some conclusions. In the longwall mining system, there are various factors in place that lead to the reduction of the utilization rate of the calendar time, which are sometimes due to the mining conditions, geological and mining conditions, for instance, certain hazards that occur. Technical and technological solutions for implementation of this mining process, the technical condition of other technical solutions at the coal mine. Unfortunately, the mining system must rely upon the haulage system, conveyors, auxiliary installations, power supply, electrical installations. All of that must work, but also the system's productivity is also dependent upon the organization and management of the process, the availability of the mining machine, and we should look for such solutions that will provide us with an increase, ensure an increase of effective time, direct run time. So all of those ineffective shown highlighted in red of the previous diagram should take as little as possible out of the daytime. Thank you very much for your attention. Good morning, ladies and gentlemen. My name is Marek Kalita. At the KOMAG Institute, I'm the head of the unit for machines and devices that specialize for longwall mining systems, perform the research and development works as part of a contract project. The project is co-financed from the funds of the European Regional Development Fund, and under the contract listed on the slide of 28th of June 2018, the contractor for this project is the consortium ITG KOMAG, AGH, Sieć Badawcza Łukasiewicz-Krakow Technological Institute, the innovative company is Limited Liability Company, and the Polish mining company PGG. The main objective of the project is to develop and implement into production the new generation of advancing system of a high-performance mining system, longwall mining system. The new advancing system versus the currently used is characterized by the accessibility of adjusting the route of a long wall coming to the variable, to the changeable inclinations of a coal face, of a long wall coal face. This feature is especially important in the case of a variable, changeable geological and mining conditions that disturb in both vertical and horizontal plane the run of the guiding rails for the installed advancement system. On behalf of the testing team, I'd like to present you the results of the tests, functional and durability tests of the newly developed advancing system for the long wall mining systems. The tests under the project were conducted on the testing station located on the ground on the storage site of the Piat coal mine. Ladies and gentlemen, the system contract advancing system is to be used alternatively with the currently operated I-contract system. The advancement system for the mining operation is made up of guide rails that are installed at the bottom where the individual segments are placed. The contract advancement system doesn't lead to the change of the structure of a scraper conveyor. It just requires the use of a miner system skid, modified versus the one that's currently used in the I-contract system, made up of individual segments with teeth root, is to interwork with the drive gear, and has to be the looseness and the initial tensioning should be provided. This function is performed by the hydraulic tensioning system installed on one or both ends of the root. As I mentioned, one of the stages of the project underway was to perform the functional tests of the newly developed advancement system on the testing station designed by ITG KOMAG. Based on the 3D models, the documentation was prepared along with indicating the main devices and machines. The PGG was responsible for preparing the testing station at the Piast coal mine. Such a testing station was completed. The tests were performed using the KSW 1140 type. The elements were installed on the Rybnik 1100 type. The miner was loaded with the braking force applied via the pulley, simulating the conditions of mining the longwall. After covering an almost 50-meter long track, the miner was returned without the load anymore, without the pulley back. We're simulating on the inclined and bent track in the vertical and horizontal planes. Simulation that performed the actual configurations due to the position of the guide rails of the conveyor scraper are shown on the slide. The goal of the test was the functional verification and durability of advancement system. After the specialist prepared the diecast of the elements of the advancement system, it was possible to verify, to prove guide rails and the elements segments, and to evaluate their mutual cooperation. First analysis performed even before starting the test enabled us to allow the verification of the scope of range of susceptibility. On the spherical, you can see the full movability in all planes, limited by the size of the canal of a duct of the guide rails. The friction pair susceptibility was controlled on an ongoing basis during the test by logging and analyzing the video images. The functional features of the advancement system and the correct operation thereof was tested also during the simulated standard operations performed on the longwall mining, such as making the preparing. It turned out that based on the video recording, that on the bends of the local, the susceptibility of the system allows for the alignment, self-alignment to the current position of the track wheel, eliminating the edge cooperation on the friction pair. Similar positive results about the correct interoperation on the friction pair can be derived from the analysis of run of miner in the vertical plane band with a 5-degree inclination angle. Ladies and gentlemen, as a result of a completed scope of tests, the advancement system contract was subjected to the total number of passes of the minor system amounting to 553 passes. One pass understood as a pass of the minor, both sides, one way and back, two-way, remembering that it was going against the resistance and back without the resistance. 0.8 meters the length of the yield of the mining, that in the simulated conditions the miner would be able to mine on a single pass 428-meter long coal face and twice as long in case of a double pass operation. During the tests, there were several failures, mainly regarding the power supply system of the miner system, but it didn't have any impact upon the scope of the rate and the pace of the test. The tests completed and the observation analysis also allowed to define the degree of wear of individual advancement system, including, among others, the gear systems. On parts of those gears, the wear of the upper surface were observed. The wears were also included the dents on the side walls due to the pressure of the track wheel in the situation when the gear was twisted in the vertical level. That's a plane. That's the proof of susceptibility that enables the movement of gear segments against each other. In the extreme cases, the above mentioned fault led to the breaking of some parts and the resistance surfaces of gear segments. Valuable information about the friction pair interworking were also provided by the analysis of the level of the wear of side surface of gear segments. As a result of simulating the distortions on the straight line route, it was determined that the wear of this side surface is dependent upon the placement of the conveyor on the straight line segment. The wear is uniform along its entire width, whereas when there is distortions of a straight line route of the conveyor, the maximum use wear of the sidewall goes towards the one side of the wall, and the shape of this surface interaction shows that the gear surface is adapting to the wheel track shape. Now I'd like to show you the numbers about the wear of gear segments. Those segments were marked and weighed before the test. It was possible to determine the weight of segments after the test. On average, each sample, as a result of test completion, reduced its weight by about 29 grams, mainly regarding the side wall of this tooth of the gear. It is confirmed by the twisting test of the gear segments based using the 3D modeling. This technique was applied during the implementation of the project twice. First, the 3D scanning was applied to scan those earlier mentioned segments that were weighed and marked. And second time, such a scaling was performed after the completion of the full test. After comparing both models, it was possible to get the average maps of deviations of changes of the surfaces of the samples tested. On the subsequent slides, I'd like to show you based on 3 selected segments, I'd like to show you the results of the tests in this respect. Based on the example of the segment as marked as sample K1 installed on the straight line track, you can see quite uniform wear of the surface of this segment, roughly along the entire width of the segment, both on the side where the braking force was applied, as well as on the other side which was responsible for the pass of the miner without braking, without resistance. The difference in the degree of wear was was demonstrated when analyzing the sample marked as A3, which was K3, which was used on the beginning of a track where there was a distortion of a straight line track took place. Here you can see the tendency to the faster wear on one side, although the shape of this dark blue color area shows that the segment, quote unquote, was trying to adjust, to align to the positioning of the side of the track wheel. On the other hand, the K8 sample mounted on the straight line part of the track behind the band of scraper conveyor shows a similar nature of wear and changes of the surface before and after the test. Ladies and gentlemen, the scanned 3D models subjected to the comparative analysis were based in an automatic manner using the selected function of the KOMEK-IMTech software. This function enables to the maximum degree to align the models being compared in order to obtain the smallest average deviation. The alignment of the two models shown in the picture in red and in blue and gray color show that the average deviation between the reference model, the one prepared before the test, and the models obtained by scanning 3D modeling of the samples after the test is about 0.17 millimeter. Ladies and gentlemen, in the presentation I presented just selected aspects of our tests performed as part of a contract product. As a result of works completed, almost 50-meter long testing station was prepared, that enabled simulating the conditions along the long-wall mining environment. The material data collected provided answers to the question of a new advancement system, newly developed advancement. There is no disadvantage to the development of edging between the segment and the wheel. The analysis of the test allows us to state that there is a susceptibility in the system due to the features of the segments, gear segments. Analysis of the places of the straight line track is showed that as a result of action of interaction between the single segment and the wheel track, there is a self-adjustment, self-adaptation of the friction pair surfaces interaction. As a result of that, there were no repeatable recurring faults on the surface of the wheel track were not detected. Thank you very much for your attention. I'd like to encourage you to follow further articles and presentations regarding the implementation of a contract project, which in December this year will be completed. Apart from the above-mentioned test, as part of a functional test, also the endurance, the strength test of the segments, gear segment, using the resistance tensometry. The results of analysis regarding this topic will be published soon. What's still ahead of us? The project consortium is facing the most important task of the project, namely the verification of a developed advancement system in the underground conditions during the run of one of the longwall headings at the Piast coal mine. The test performed by the Institute will allow us to confirm the assumptions adopted regarding functionality and its usability of the advancement system, and will allow us to compare it to the currently used system. Thank you very much, and ladies and gentlemen, Mr. Chairman, ladies and gentlemen, Tomasz Czerwiński from Politechnika Śląska. I'd like to present you the paper about the effective method of drilling using the torsion generator. The effects presented in this presentation related to the new method of drilling using the torsion generator is a part of a broader project performed as part of the European Coal and Steel Funds under the acronym INDIRES in the 2017-2020 years. As part of the project, several units were involved. The leader of the project, University of Exeter from Great Britain, Institute of Innovative Techniques KOMAG, the KOMAG Mining Technology Institute KOMAG, where I come from Spain, Politecnica Śląska, Charles III University from Madrid in Spain, the Central Mining Institute, the Morning Program Delenie, Slovenia, DMT, DMGH, GmbH, Germany, Polish Mining Group, PGG. In this presentation, I will present the topics related to the design of a drilling rig, components of the drilling, such as a generator of a torsion generator with a torque inverter, the main drive motor. I will present you the implementation of a mathematical model of a drilling rig in the MATLAB software. I will also present the field calculations, also the auger, the screw conveyor, the mining head, and the control system. Designed jointly with KOMAG, the drilling rig system is made up of several major components. The main drive motor, this could be the induction motor, the motor with permanent magnets, inductive torque inverter, torsion generator, mining head, and then internal auger. The main drive motor generates the torque that is transferred via the induction torque inverter to the torsion generator. Here the torsion generator to a certain moment to the torque is adding the alternate torques that are then transferred to the mining head. The extracted, the mined material is transported internally via the auger, and the main drive motor powers the auger, the screw conveyor. On the drawing doesn't show fully the full configuration of this auger. The electromagnetic torque generated by the main drive motor, TEM, on the drawing feeds the mining head via a part of the electromagnetic torque designated here as TEC. It also feeds the auger via a part of the ES torque, and we also have a certain losses of torque in the bearing mounting system or in the ventilation system, and generally speaking the cooling system of the torsion generator. The electromagnetic torque component TEC responsible for the propulsion of the mining head is transferred by the torque inverter. In the torque inverter we have certain losses as well related to the ventilation of inverter torque marked as TECL, and a part of it torque T1 is delivered to the torsion generator. In the torsion generator we have additional components of electromagnetic torque. The electromagnetic torque of asynchronous torque nature, and the electromagnetic torques related to the higher harmonics of the electromagnetic field, the so-called flow harmonics. These are alternate harmonics depending upon the frequency of the power supply line of different frequencies, and also dependent upon the resultant speed of rotor of generator itself. So therefore we have several methods here in place that allow us to shape the course of electromagnetic torque and the torque on the mining head through the torque coming from the main driving motor, through the electromagnetic torque of asynchronous torque from the torsion generator, and then through the alternate torques, changing accordingly the frequencies of the power supply of the main drive motor of generator, we can shape the content of alternate torques on the mining head. The important part played by the torque inverter, which is important for point of view, is the fact that it couples the two main components, the main driving motor and the torsion generator, but in a contactless manner. It's a electromagnetic coupling, as a matter of fact. It's performed via the discs with permanent magnets that generate the rotating the magnetic field, and the disc made up of windings to work on the so-called short circuit. A certain force being generated that allows for transferring the electromagnetic torque from the main driving motor to the torsion generator. Some harmonics, spatial harmonics of a magnetic field generate the alternate torques, and in this specific case, in the case of a torsion generator, the harmonics pairs that generate the alternate torques 226, 88, 110, 82, and the second set representing the 22, 34, 22, 50, 62, 106, and so on, and the third set 10, 38, 10, 36, 94, 74, 94. To individual harmonics you can assign the coefficients of the windings of the rotor and the stator. If we divided the winding coefficient of the stator and of the rotor, we can get quite interesting bar graph that is shown at the bottom part of this slide. That's where you can see which harmonics, which of the harmonics pairs earlier mentioned generate the torque with the highest amplitude versus the main asynchronous torque. Those frequencies, the formulas are the functions of RPM speed, and they generate characteristic V-shaped curves that you can see on the right-hand side drawing. If we have RPM close to the nominal, to the rated speed RPM of the torsion generator, about 3,993 RPMs. In this case, if we were to increase the load, or for some reason the RPMs of this generator rotor would go down to 1,000 RPMs, you can see a major change in the frequencies of the torques generated. We can of course compensate this decline by raising the frequency of the power supply system, but also treat it as a desirable feature in the drilling process. And now the important element that was developed, that was compiled as part of this project, is the electromagnetic torque inverter. This inverter's task is to separate two components of the drilling rig, the main motor from the torsion generator. Here the transfer of drive torque from the main motor to the torsion generator is carried out via the interaction between the spinning electromagnetic field from the permanent magnets and the induced field in the windings of the armature with frequency inverter, and thanks to that we don't have a mechanical coupling between the shaft of the motor, and here it is marked as shaft number 1 on this drawing, and the shaft connected to the very generator. This way the main driving motor is protected against the torsion torques that do not get directly to the shaft of the main driving motor. In our project we decided that to choose as the main driving motor the variant equipped with the permanent magnets. The main contraindication that we came up against was the appropriate designing of a magnet to minimize the so-called cogging torques. On the right-hand side, you can see three curves of a torque depending upon the various length of the permanent magnets. The first package is 114 millimeters, the second 120 millimeters, and the third 150 millimeters. The torques generated by this driving motor are between 50 and 100 Newton meters, depending upon the length of the stator package and the package of permanent magnets. But we can see that the application of simple permanent magnets causes quite significant fluctuations of magnetic torque. These are the so-called cogging torques, which may bring about difficulties when starting up the motor itself. Therefore, the decision was taken to split the rotor into two even parts, two cylinders with equal lengths, and they were twisted versus each other by a small angle based on the scale of the stator. As a result, a smooth course of electromagnetic torque was obtained in all analyzed cases of the length of the motor, and the maximum amount value is achieved 100 Newton meters, 75 Newton meters, and almost 60 Newton meters, depending upon the length of the package of the stator and the package of the rotor with the permanent magnets. Ultimately, the mathematical model was developed, represented in as a pair of the differential equations of the entire drilling rig. You can see this kinematic chain in the central part of the slide. It's a model made up of 1, 2, 3, 4, 5 inertia masses. So this model includes 5 degrees of freedom of movement. Each component, the motor, the main motor, equipped with permanent magnets, is marked here with digit 1. Torque inverter is designated here on the drawing with digit 3. Torsion generator, digit 5, torsional generator, and the very kinematic chain of the drilling rig is marked here with number 4, the subsystem. All the mathematical models of all those components were implemented in the MATLAB software, MATLAB Simulink software. The basic experiment was carried out, which involved increasing gradually the load of the mining head, and the result that we can see on the left-hand side, this is the characteristic of torque. The torque directly affecting the mining head. We can see the amplitude increasing of alternate torques. The content of the harmonics in the final period, in the period between 4 and 5 seconds, we can see in the central part of a drawing. We performed a fast Fourier transform, calculating the harmonics. We can find the harmonics of 41 Hertz, frequency about 158 Hertz, 424, and so on. The element developed jointly with the KOMAG unit by KOMAG is the mining head and the very auger. This part presented on this drawing is made up of the following sub-assemblies. From the connecting module connecting the mining head with the torsional generator, the enclosure with the ceilings, the transportation tube marked here in yellow, internal auger shown in violet color, here purple color, the enclosure of the bearings, the needle bearings, support bearings, the driving shaft. This is the shaft on which the driving torque is transferred from the torsional generator, the resistance bearing, the sealing systems, and the very cutting head. In the process of our tests, field calculations were completed. The goal of those calculations was to examine the stresses in the auger, in the shaft, in the mining head. As you can see, the stresses are at an acceptable from the technical point of view level. The power supply and the control system was designed. As you can see, it's made up of two basic elements: the battery, a set of lithium batteries, including the protection system, as well as the inverter systems, including the additional protection components that include connections, connectors, transducers, charger, controller, switch, and the inverters. The power and control system is made up of two inverters: frequency inverter 1, frequency inverter 2, as shown on this. To power accordingly the main motor, to feed the torsional torque generator. The control system is not only dealing with RPM control for the entire system, but the control of the loading process, the charging of the battery system, and it interworks with the hydraulic system that provides the appropriate coolant for the drilling rig. On this slide you can see my contact details. Once again, thank you very much for your attention. Good afternoon, ladies and gentlemen. I'd like to present the presentation under the title Simplified Numerical Simulation of the Behavior of a Rock Mass of a blocky structure in the vicinity of a long wall face in the context of selected theoretical analysis and the measurements of the distribution of the operational pressure in the vicinity of the front of a long head. Due to the limited time of the presentation, I'd like to just highlight certain problems, issues that accompany the performance, the behavior of the rock masses in the vicinity of a long wall heading, but I will not be describing those developments in detail. This is due to the limited time available. Each of these developments of phenomena could be subject of one or even more papers, as Professor Kwiatek writes, getting to know the state of the stress in case of mining, long wall mining, is a complicated issue. Is first of all due to the size and the scale of in the given rock mass, and diversity of rocks, and the geomechanical properties in the vicinity of a long heading makes it problematic to make assumptions regarding the uniformity, isotropic nature, and also the continuity of the analyzed rock masses surrounding the long wall heading. Good afternoon, ladies and gentlemen. Let me present the presentation under the title Simplified Numerical Analysis of Rock Masses Behavior of Blocky Nature. Let's move on to slide number 2. The issue of the distribution of stresses in the vicinity of a long wall mining heading is so complicated that there's a lack of universal theory that would demonstrate the full compliance of the results for various theoretical conditions with the actual observation. And particularly important is the problem of stability of the floor strata in case of a high strength hanging over the floor, in the abandoned workings. For the first time, Maffeo used the term pressure arch with respect to the arch laid strata. Rupenite in 1954 developed the theory of layers of strata bending, and in 1968 Professor Antoni Saustowicz, considered to be the father of the Polish mechanics of rock systems and geomechanics, expands the thought of Budryk of 1933 about the use of the theory of beam on the flexible foundation to analyze the issues regarding the distribution of stress when mining the coal seams with the floor. This assumption, the assumption is that the direct roof is caving is when supported is subjected to the caving. One of the main theories that describes the stresses around the pressures around the long wall heading is the wave pressure system. Generally in this solution the floor roof of H thickness is burdened with a uniformly distributed overburden pressure, and the beam is treated as a flexible foundation. The floor, if you look at the formula describing the maximum stress in the neighborhood of the front of the long wall, this value of the stress depends upon the PZ, so the primary pressure is the L, the length of the support above the area already mined, space already mined, and the C1 factor, the resistance of the right seam as the flexible foundation, E, the Young module, the flexibility module, and the I, the inertia moment of the roof beam, and it depends upon the thickness of the roof. The second of the best known theories regarding this analytical solution is the theory of a beam on the flexible foundation. If you again look at the formula describing the maximum stress value, we can observe that the value of the stress depends upon the values that are already mentioned, and additionally you get M, which is the thickness of the seam, H, the thickness of the roof beam, and the Poisson coefficient for the roof rocks. In case of both theories, the maximum value of the pressure appears directly at the front of the long wall face. As, however, indicated by the measurements of the stresses in the vicinity of the long wall face, the distribution of the stresses is different than the theoretical solutions presented before. If we look at the first of the graphs on the left-hand side thereof, on the vertical axis we have the stress value, on the horizontal axis we have a distance from the front of the long wall face. The maximum stress value is away from the front of the long wall by about 5 meters. On this graph, based on this graph, you should conclude that the exploitation is performed from the right-hand side to the left-hand side. On the right-hand side graph, Professor Majewczyk is quoting, following Professor Borecki and Hudek, the distribution of stresses in the vicinity of the long wall heading, long wall working. This is this thick black line, black curve. according to this distribution based on the measurements of the stresses around the long wall heading, also the maximum stresses appear at a certain distance from the face of the long wall. In case of this drawing, the exploitation, the mining is carried out from the left-hand side toward the right-hand side. Similar, Professor Konopko, drawing the distribution of stresses in the vicinity of the front of the long wall. These are the curves that I mean, is shifting the maximum value of the stress to placing it in ahead of the front of a long wall face at the distance of about 4 to 8 meters, taking into account the geometry of the working. Blocky structure of a rock system. In the early years of last century, there were a series of disasters in coal mines and in various systems, including the Czesagi, considered the father of and Voigt, writing the limits for forecasting the consequences of disturbing the state of equilibrium in the ground and rocky systems as a result of engineering activities. Disasters happen also in tragic disasters in the coal mines. In South Africa, 432 miners died in 1960 as a sequence of rock bursts. Miners die in the gold mines in South Africa and India, and the nickel mines in Canada, and the coal mines in US and Australia. Tens of disasters in the mines that exploit raw materials and the underground structures lead to the conclusion that the abilities for analysis of the problem, geoengineering problem based on the existing solutions, technological solutions based on the flexibility theory and treating the rocky systems and ground systems as quasi-uniform, continuous and isotropic. For designing and assessing the quality of the rock masses, the geological quality of the rock systems are started to be used as a taking into account its discontinuities, divisions, and anisotropy. One of the examples is the GSI, Geological Strength Index, which is the basis for a number of other solutions for evaluating the stability and the damage conditions, destruction conditions of the rocky system. For instance, the Cronin-Brown. Another example is the classification based on the D rock system damage. For the untouched maiden rocks, the D is 0, and for the strongly cracked, affected, almost crushed, D is 1. In case of boring using the explosive in a very careful manner, the value of the D indicator is equal to 0. The distinct element method versus other numerical methods. The most important, most widely used methods for modeling, numerical modeling used in the geoengineering is the finite element method, the boundary element method, the finite difference method, the distinct element method, and the discrete element method. The discrete element method is created by the finished movements, the distributions and rotations of the discrete bodies, ability to totally differentiate, separate the discrete bodies, recognizing new contacts between the moving bodies as the calculations progress. The distinct element method, the separate discrete bodies are connected via bonds. The separate bodies can be subject to movement, rotation, get away from each other and touch again. The interfaces between the bodies are deformable. It could be rigid or deformable. The direct step-by-step for solving the movement equations. The assumptions were described by Peter Kandel in 1971, then by Kandel and Struck, and subsequently by Kandel and Hart. In the general case, the distinct element method assumes that the particles in the shape of polygons are subject to deformation. The effect interaction of grains or blocks is treated as a dynamic process, changing under the impact of internal forces, the forces of interactions, movements of aggregates of elements, of distinct elements, discrete elements, are dependent, the deformations depend upon the dislocations, movements of single particles. The UDEC program was described repeatedly also by the authors themselves. Generally, in the UDEC program, the models are built of polygons, discrete elements, distinct elements that could be of different shape and size. They could be rigid or deformable. Using UDEC program, simulation made numerically performance of the rock mass in the vicinity of the long-hole heading, tests of uniaxial compression of anisotropic rocks, behavior of rock masses of rocky nature subjected to the underground operation, stability of a rock system and the underground hockey stadium in Norway, the bridge in Shida, the phenomenon of explosive processing of rocks, methane migration from the floor layers, properties of the process of a settling of a post-mining area. The simulation was of a beam bending, behavior of roof layers in the longwall heading were simulated. The selected example of the use of the UDEC program, numerical modeling of the rock masses of layer and block in nature, and examining the discontinuous deformations accompanying the longwall heading with roof caving, numerical analysis of the migration from the floor layers to the longwall heading. Numerical simulation of exploitations conducted using the longwall mining for the rock mass of the rocky nature, of a blocky nature. The model was built using the UDEC program version 5. The model disk was 1500 meters across 500 meters over the coal seam with a thickness of 3 meters. In the floor, 29 rock layers were simulated with the thicknesses, and in the floor 6 layers were simulated. The exploitation was simulated on the segment of 400 meters. All layers were given the features of the carbon rocks, and the Coulomb condition was assigned, and the points on the constrained ability to move along the axis, horizontal and vertical. It was assumed that the floor of the seam is situated at the 800 meter level. In order to simplify the model, the vertical component of the vertical stress was only a fragment of the rock mass was modeled. The model assumed that the weakening plane, the cracks of the width equal 0, run at the angle of 90 degrees versus the rock layers, and vertically separating the individual layers. The distance between the vertical cracks is different. It varies between 2 and 144 meters. The blocks themselves were granted the features of the deformable materials. On the right hand side, in the upper part, below you can see the split of the model into blocks. At the bottom on the left hand side, zooming in on the vicinity of seam, blue shows the coal seam, and above that, direct vicinity of front of longwall face. The floor layers, the roof layers, the exploitation direction. Blue shows the unmined yet parts of the coal seam. the caving-in zone and the powered support. The UDEC enables modeling different types of supports. Here the support was modeled using the deformable blocks. The first stage of the exploitation, 25 meters long wall length, the condition before beginning of the calculations, the condition after completing the calculations. You can see the band of the roof layers and the cracks that appear between the blocks. The distribution of vertical dislocations, displacements. Red color shows the vectors of vertical displacement. You can see the concentrations of those vectors in the roof caving part zone. The distribution of the largest stresses, the zones where the stresses are concentrated before the front of the loading in the end part and under the support system itself. The decline of compression stresses in the roof layers above the mined part of the coal seam. The length of the long wall, 250 meters, the coal face length. The model after the calculations, you can see the cavings and the dislocation displacements of the blocks and the cracks separating the caving blocks below. Distribution of vertical displacements in the caving zone. The falling blocks almost touch the floor of the seam. The distribution of the vectors of the vertical displacements, also the concentration of those vectors in the caving zone, floor caving zone, and the distribution of the largest main stresses, the zone of the concentration of the stresses before the front of the long wall in the powered support itself or in the left back support. Decline of compressing stresses and stretching stresses appearing in the floor caving area. The model after the exploitation of a 400-meter long coal face in the right-hand corner at the top, you can see the model, the blocks in the caving zone. Good afternoon, ladies and gentlemen. Welcome. At the end of our conference, Mr. Professor, yes, the final moments. First of all, I'd like to apologize that in the panel that I was the initiator along with the professor, I did not manage, unfortunately, to take part, but we had a meeting of the management board. I was just not able to leave, but I know it was very interesting. It was the peak in terms of the number of viewers, 2,000 hits over 2 days and 1,000 hits in the second day. That's always during conferences is a bit of a difficult day. It just demonstrates that what's the power and that's the potential, and I'm very frank here, in the KOMAG Institute. Please believe me that JSW has already held such conferences, and to focus so many participants interested in such a topic, and the internet doesn't excuse and verifies it very quickly, and you can see the people that are simply connected. So we have them. So I'd like to thank the professor very warmly. There are participants involved, and I also talked to some of the authors. What level, I think, Mr. Professor will say a few words about the level, quality level. On my side, the employees of the JSW company that were listening to the conference in the company that were actively participating, we are very happy, we are very satisfied, and we would like some of those ambitious concepts, very ambitious concepts that we didn't expect to occur, but they translate into projects that we'd like to test, verify in the semi-technical or technical level. From this spot, I'd like to thank you very much. As one of the co-organizers, I can say that, Mr. Professor. Yes, that's correct, Mr. President. Please allow me, and I always emphasize that it would never have been happened had it not been for the engagement of a team that we managed to set up at JSW. Therefore, here, from this spot, I'd like to thank once again the management board of SIG, which is our training and mining subsidiary, and the employees that are very highly involved, engaged, and cooperate with the people from the professors here, team here, and it's going very well. I would like this JSW to continue to be a learning organization. Who should we learn from? When if it wasn't for the specialists that we were working with over the last 2 days and the technicalities, it wouldn't have been heard. It wouldn't have been heard and seen if it wasn't for JSW IT systems company that is doing its best, and I think we didn't experience many difficulties, technical difficulties. And now what I'm most interested in, we have had talks with SIG management. We decided to place all those materials for you on a website and the profile of the training and mining, and we consider this material to be up to date all the time, and material that could be also retrieved again, and will end up with practical application. In my hand, congratulations, Mr. Professor, on the conference. All of you, ladies and gentlemen, for taking part. Congratulations on this participation. This conference, we are in a big family, mining family, and for me, the processing is a certain very important part of the mining process. We are strongly fighting within JSW to make sure that mining is viewed from the entire chain, that it goes from the deposit to the sea, from mining, processing, coke, and reload on the ship in the sea, the best quality that can place on the market. And you have seen, and also safety, green energy, green mining. Processing is important. We are waiting for interesting proposals, ideas. The strategy of JSW company that's created by the Ministry of State Assets is directing us towards increasing the potential for the coking coal output. We have things to do on these processing plants. And thank you very much. Congratulations on all the speakers. I know that there will be publications. So therefore, ladies and gentlemen, we're waiting for more. Thank you very much. Looking forward to more. Also, thank you very much, Mr. President. Ladies and gentlemen, that's true. Some presentations were replayed. I was listening with a lot of interest, not far from being fascinated by them. The topic extended by adding the processing topic extended by other topics related to the natural environment protection and safety made this conference, although a bit exotic, continuous continued to circle, focus around the KOMEKO name, ecological and for the mining. So whether for mining or a bit further out, always somewhere around this mining. As Mr. President said, the statistics, the highest statistics were during the discussion. Unfortunately, Mr. President wasn't available, wasn't present. I was trying to excuse him. I must say that despite the absence of the President, but there's an opportunity to do another conference and take part again, always with Mr. President. Well, if you allow me, I'd like to thank the presidents of Bogdanka and Talon Wydobycie that we talked to personally, to get them involved, and I know the involvement was active, they were engaged, they were active, spontaneous, basically without a scenario, without a screenplay. We were circling around topics of the existence of co-processing and the basics for the future existence of the manufacturers of the devices and machines involved in the processing. That's how to be or not to be around this transformation. But, ladies and gentlemen, the conference would not have been held had it not been for the organizational teams from KOMAG, from SIG, JSW, and the ITS systems, and the contribution of JSW company itself. The conference was able to be prepared this way thanks to our partners, sponsors, FAMUR, PPG, then the Nord company, ProIdea, excuse me. So those companies also provided support to us. The honorary patronage was taken over by the Minister of the State Assets. Also, we were granted the patronage support by the President of the Central Mining Institute and the Marshal's Office. I'm very happy for all that to happen. But finally, Mr. President, I'd like to say that the fact that the conference is online is to a large degree thanks to you. What you can see here, JSW company, training and mining and IT system subsidiaries. I'd like to express certain thanks by awarding certain minor gifts for Mr. President. I wasn't expecting that. Thank you very much. We are also surprised. So on the hands of Mr. President for JSW, please, for the entire management board, please, on my behalf and on behalf of KOMAG, and I'd like to ask Mr. President Augustyn, so that for JSW training and mining also I'd like to hand over a small, and Mrs. Aldona, ladies and gentlemen, please, also from our side, from KOMAG, thanks, and Mr. Director Miara, who is representing the IT Systems JSW subsidiary also. Mr. Director, we disinfected our hands so I can shake your hands, and I'd like to thank everyone. Without you, this event would not have happened. So that's why, thanks to that, you also will keep us in your memories. Thank you very much once again. I'd like to greet the KOMAG connections, and I'd like to invite you to further events that I will be informing you on ongoing basis. We have further conferences ahead of us. The fair in Katowice would like to try to broadcast our open events such as the scientific and research seminars. So I wish you all the best, and I wish you success in the near future. Thank you very much. Ladies and gentlemen, be with us. It's definitely worth it. I keep saying that. Someone recently asked me, how will the company be defending itself? JSW is not defending itself. It's attacking all the time. It's on the offense all the time. And be with us in this offense. Thank you very much.
Technologia VR, a więc rzeczywistości wirtualnej, jest narzędziem przyszłości edukacyjnej z powodzeniem wykorzystywanym już od dłuższego czasu w programach szkoleniowych spółki JSW Szkolenie i Górnictwo. Tamtejszy system VR jest tak skonfigurowany, iż może być rozbudowany o nowe komponenty edukacyjne. Najnowszym są fantomy, które współpracują z technologią VR, otwierając zupełnie nowe możliwości szkoleń z zakresu pierwszej pomocy przedmedycznej, a więc wiedzy i umiejętności, które mogą zdecydować o ludzkim życiu i zdrowiu.
Wykorzystywanie technik stricte praktycznych do nauki tak ważnej dziedziny, jaką jest niesienie pierwszej pomocy, pomocy przedmedycznej w zakładzie pracy, tutaj w tym przypadku jakim jest kopalnia oczywiście, jest bardzo ważne. Wiedza teoretyczna, znajomości podstawy zachowania się w pierwszym etapie jest bardzo ważne, ale praktykę, ćwiczenie tego właśnie z wykorzystaniem aplikacji VR, z wykorzystaniem fantomów, prawidłowe uciski, prawidłowe sprawdzanie oddechu. Jest to najważniejszy element i stąd właśnie pomysł w Spółce Szkolenie i Górnictwo, aby rozpocząć szkolenia wśród kadr, którzy mają świadczyć tą pierwszą pomoc przedmedyczną, tak zwani sanitariusze, aby ich poziom wiedzy właśnie z zakresu praktyki, bo teorię mają, jak najbardziej właśnie z nich wykrzesać i sprawić, aby gdy dojdzie do niesienia pomocy, ona była jak najbardziej skuteczna.
Fantomy z aplikacjami VR pozwalają na indywidualny tryb szkolenia praktycznego, które jest dostosowane do umiejętności i predyspozycji każdego kursanta. Wirtualny instruktor precyzyjnie kontroluje czynności ratownicze podejmowane przez uczestnika szkolenia. Aplikacja jest tak zaprojektowana, aby podpowiadać kursantowi właściwy sposób postępowania z korekcją błędów do momentu prawidłowego wykonania czynności ratowniczej.
Na tyle będą wypracowane powtórzenia, aby nabrać tego prawidłowego zachowania. Także wykorzystanie właśnie aplikacji w tym zakresie, stricte udzielania pierwszej pomocy jest najlepszą teraz formą szkolenia moim zdaniem.
Fantomy z aplikacją VR służą nie tylko do praktycznej nauki resuscytacji krążeniowo-oddechowej, czyli sztucznego oddychania i masażu serca, ale także prawidłowego korzystania z defibrylatorów.
Jak go prawidłowo elektrody rozmieścić, jakie po kolei czynności wykonać, aby jeżeli będzie konieczność użyć tego defibrylatora.
Zalety wirtualnego systemu nauki pierwszej pomocy doceniają także kursanci.
Właśnie jestem po skończonym szkoleniu VR. Jestem zaskoczony możliwościami tego projektu. Aplikacja daje mnóstwo możliwości rozwoju umiejętności praktycznych.
Spółka JSW Szkolenie i Górnictwo już teraz zaprasza wszystkich zainteresowanych zdobyciem wiedzy i umiejętności z zakresu pierwszej pomocy na bezpłatne zajęcia, które w ramach Dni Otwartych zaplanowano na czerwiec tego roku.
This is the 18th edition of the International Fair of Mining, combining 350 exhibitors from 12 countries, 26,000 square meters of space.
Please join us on the stage.
Zero, zero, 152.
Województwo śląskie oferuje wiele rozwiązań dla biznesu. Natomiast Międzynarodowe Targi Katowice 2021 to wyjątkowe wydarzenie. Dlaczego warto się tu spotkać?
19. edycja Międzynarodowych Targów Górnictwa, Przemysłu Energetycznego i Hutniczego Katowice 2021 już przed nami. To jedno z największych wydarzeń w Europie i trzecie na świecie. Spotkamy się już między 7 a 10 września 2021 w Polsce, w Katowicach, Międzynarodowym Centrum Kongresowym oraz na placu przed Spotkiem.
Nadchodząca edycja targów Katowice 2021 została wzbogacona o Międzynarodowe Targi Energetyczne B2 Energy Poland.
Jako organizatorzy przygotowaliśmy dla Państwa ponad 60 000 metrów kwadratowych powierzchni targowej.
Katowice jako serce województwa śląskiego to miasto otwarte na biznes i przyjazne inwestorom. Znajdujące się w nim Międzynarodowe Centrum Kongresowe to wyjątkowy obiekt, który został wyróżniony jako jeden z najlepszych kompleksów do organizacji konferencji, kongresów oraz targów w Polsce.
Oprócz naszych targów, Międzynarodowe Centrum Kongresowe gości również 5. Polski Kongres Górniczy, Europejski Kongres Gospodarczy i wiele innych.
Dla przemysłu istotna jest branża energetyczna i elektryczna, która podczas targów B2 Energy Poland Katowice 2021 ma doskonałą przestrzeń do prezentowania innowacyjnych urządzeń i technologii. Targi o charakterze międzynarodowym to świetna okazja do podjęcia współpracy z międzynarodowymi koncernami energetycznymi i odbiorcami końcowymi.
W odległości 100 km 3 duże lotniska: Katowice, Kraków, Ostrawa. Dojedziemy do Katowic szybkimi trasami i autostradami, jak również znajdziemy tutaj szeroką bazę noclegową, a tereny wystawiennicze okalają parkingi. Podczas ostatniej edycji targów gościliśmy ponad 350 wystawców i odwiedziło nas 30 000 zwiedzających, w tym delegacja z całego świata.
Jako organizatorzy wspólnie słuchamy i dopasowujemy się, by stworzyć idealny klimat spotkań do rozmów o kierunku rozwoju tej strategicznej branży. Rozmowy toczą się na płaszczyźnie krajowej i międzynarodowej. Organizator targów gości delegacje zagraniczne dzięki współpracy z miastem Katowice i Izbą Gospodarczą.
Tych wszystkich, którzy się jeszcze nie zdecydowali, zapraszamy na Międzynarodowe Targi Górnictwa, Przemysłu Energetycznego i Hutniczego Katowice 2021
oraz Międzynarodowe Targi Energetyczne B2 Energy Poland.
Spotkajmy się na targach od 7 do 10 września 2021. Katowice. Miasto przyjazne biznesowi.
Sytuacja na rynku pracy w sektorze górniczym jest i będzie bardzo zmienna. Dzieje się tak z przyczyn niezależnych zarówno od pracodawcy, jak i pracowników. Zmiany, którym górnictwo podlega, wymagają od osób w nim zatrudnionych lub poszukujących tam pracy nieustającego podnoszenia lub nabywania nowych kwalifikacji.
Spółka JFW Szkolenie i Górnictwo opracowała pilotażowy projekt górniczej aktywizacji zawodowej. Dzięki temu dajemy szansę górnikom, jak również mieszkańcom Śląska utrzymania miejsc pracy w górnictwie. Szansą jest edukacja, czyli podniesienie lub nabywanie nowych kwalifikacji zawodowych w górnictwie.
Projekt Górnicza Aktywizacja Zawodowa GAS finansowany w całości ze środków Europejskiego Funduszu Społecznego przeznaczony jest dla osób, mieszkańców województwa śląskiego, pracowników bądź byłych pracowników jednostek organizacyjnych spółek węglowych lub przedsiębiorstw z nimi kooperujących. Projekt przeznaczony jest dla osób zagrożonych zwolnieniem, przewidzianych do zwolnienia bądź już zwolnionych. Projekt pozwala podnieść swoje kompetencje oraz kwalifikacje zawodowe, zyskać nowe atuty niezbędne na współczesnym, dynamicznie zmieniającym się rynku pracy.
Projekt Górnicza Aktywizacja Zawodowa GAS to nie tylko kursy zawodowe służące podnoszeniu lub zmianie kwalifikacji. Spółka JSW Szkolenie i Górnictwo wspólnie z Akademią Górniczo-Hutniczą z Krakowa przygotowały też studia podyplomowe.
Jednym z ważniejszych elementów projektu Górnicza Aktywacja Zawodowa są studia podyplomowe, które będą prowadzone w Akademii Górniczo-Hutniczej w Krakowie. Uważam, że projekt jest ważny i potrzebny społecznie, dlatego zachęcam do udziału w nim.
Szczegóły na stronie www.jswsig.pl. Projekt Górnicza Aktywizacja Zawodowa GAS.
Here I am in the heart of our Nord product range. Nord Drive Systems manufactures a very large range of drive technology products. Gear units, electric motors, electronic drive technology and industrial gear units. The overall portfolio is a unique modular system from which individual solutions can be created for our customers. Our most well-known drive systems consist of a motor and a gear unit, the geared motor. Our drive systems can also be extended by frequency inverters. Here we have a decentralized solution, also available as control cabinet version. The most complex systems can be seen here. They are used for higher torques or powers. Nord has therefore developed the Max Drive Industrial Gear Unit series, including various integrable components. The almost infinite combinations allow for a drive that perfectly matches the requirements. Let me show you an example. This drive system, consisting of industrial gear unit, electric motor and fluid coupling, is mounted on a swing base. You can also choose an IEC motor attachment, use B5, B14 flanges on the output side, mount a modular external backstop installation, and choose many more product options. Here is another example, a typical application, a belt conveyor drive. Consisting of electric motor, coupling solution, industrial gear unit with axial fan for achieving maximum thermal limit powers, mounted on a swing base. Realized from our modular system. Here is a typical application, a mixer drive, consisting of agitator flange, max drive industrial gear unit, IEC adapter for fitting a Nord electric motor, and a decentralized frequency inverter from Nord, vertically mounted from the modular system. And we also have the perfect drive system for you.
In production industries, there is a rising demand for reliable systems to monitor plant condition. Nord has recognized this need and produces predictive maintenance solutions to increase availability and make it easier to plan service and maintenance. Nord modular industrial gear units are available in 11 sizes with powers of up to 4,000 kilowatts and torques of up to 250 kilonewton meters. In our application test area, we demonstrate the opportunities of digitalization for gear unit operation and maintenance. On a test bed, operating states are simulated by two interconnected industrial gear units. The gear units are equipped with sensors for speed measurement, temperature monitoring, and intelligent vibration analysis. Among other things, this shows how unscheduled downtimes can be avoided, availability of plant and machinery can be increased, and their value can be preserved. Sensors record the necessary basic data for the Nord cloud solution. For example, they monitor vibration or temperature. Integration of other sensors, such as oil level monitoring, is also possible. Via the frequency inverter, the data are available for power and torque analysis. The data are processed by the frequency inverter with an integrated PLC or are sent directly to a gateway. Via the gateway, the data are then sent to the cloud so that they are available for evaluation and analysis from anywhere in the world. To avoid unnecessary data traffic, the local intelligence ensures that data are only sent if their values have changed. The logged and analyzed data are available in a web interface. During a learning phase, the reference state is first recorded. Information from databases for the individual components is used for this. The operating state is compared with the reference state in real time using intelligent algorithms. This enables precise conclusions about the state of the monitored gear unit components, such as gears and bearings, in each stage. Warnings are automatically sent to the cloud if abnormalities are detected. This enables optimum planning of servicing and ensures the availability of the plant. This means that a deterioration can be detected before damage is caused. The application test area also demonstrates the added value of modern data analysis, even in plants without predictive maintenance. Alarm thresholds for faults can be set up to shut down the plant in case of an alarm. Detailed analysis of the data enables in-depth examination of the damage symptoms. The frequency analysis enables conclusions about the part which is causing the measurement change. Therefore, faults such as bearing damage or gear wear can be identified and localized. Predictive maintenance provides great added value for plant operators. Availability is increased. Maintenance costs are reduced and servicing can be planned more efficiently.
Nord Drive Systems has expanded its industrial gear unit product portfolio with a new product line. This gear unit can be especially effective for belt drives used in all areas of bulk handling. We are talking about the MaxDrive XT. XT means extended thermal capacity. As indicated by the name, this gear unit has an exceptional property. Compared with many other drives of comparable size, it has a significantly improved thermal limit power. That means very high drive powers without additional cooling can be used with this gear unit. Especially for the bulk material handling industry, this is a great advantage. The exceptional high thermal limit power is achieved by different devices. A heavily ribbed housing with a surface increased by the factor 2.5, a high efficiency axial fan, and a CFD optimized airflow with a corresponding baffle design. The area with the strongest heat generation on the drive shaft is hereby optimally cooled. A CFD analysis demonstrates the strong cooling effect and the optimized airflow, especially in the drive area. Compared to the MaxDrive gear unit, this results in a considerably increased thermal limit power. MaxDrive XT also follows the Nord concept of one-piece housings. This structural principle achieves more accurate axis positions, and the gear unit is more torsionally rigid. This results in significantly higher operational reliability and less maintenance. These unique properties perfectly qualify our new MaxDrive XT for belt conveyor drives. For these applications, Nord offers complete drive units consisting of gear, motor, coupling, brake, and swing arm, individually tailored to the customer. This is the optimal solution for drives in mixing and agitation processes, optimized with leading companies from the sector for the sector. To illustrate the differences, let me show you which elements are not required anymore compared to the classic version. Wear-prone and therefore maintenance-intensive seals belong to the past. just like the bulky oil tank. Let's have a closer look at the new concept. Here we have a drive system consisting of gear unit, IEC or NEMA adapter, and electric motor. And this adapter makes the difference. We call it SOFOMI, sealless adapter for mixers. Compared with the old solution with an oil tank, the oil level can be significantly reduced and is approximately here. The lubricant heats up during operation and the volume increases. Thanks to the new solution, drive shaft seals can be omitted. When the lubricant heats up, the volume of the adapter can therefore be used to compensate. For you, this means excellent operational reliability, compact and simple design, fewer wearing parts, improved thermal properties, and hence less maintenance. SOFOMI, always the first choice for new installations and with easy retrofitting.